Ladies and gentlemen, this is Vibrant Gujarat Regional Conferences, Kutch and Saurashtra. आप सभी का हम स्वागत करते हैं. रिक्वेस्टिंग एवरीवन टू प्लीज़ बी सेटल्ड एंड एक और सूचना की जो कैमरास लगे हैं उसके सामने आप अगर खड़े हों तो ऑब्स्टिकल ना हो, उस हिसाब से आप प्लीज़ केयर कीजिए. धन्यवाद. दिस वाइब्रेंट Gujarat Regional Summit 2026. It is to promote Gujarat as an attractive investment destination and facilitate partnership and collaboration across different sectors in Kutch and Saurashtra region. And this is Ceramic Conclave for Viksit Bharat Quality Meets Global Competitiveness. Myself, Divya Thakkar, welcoming you all in this beautiful and purposeful day and the first seminar of the day. So, Ceramic Conclave for Viksit Bharat Quality Meets Global Competitiveness के इस conclave में सबसे पहले I would like to invite in front of you guys Shri Harish Bopalia, President Morbi Ceramic Manufacturers Association. So please have a seat here on the dais. Everybody put your hands together and let's welcome him. Welcome, sir. Mr. Manoj Bhai Arvadia, President Vertified Tiles Division, Morbi Ceramic Association. Please welcome. Dr. Parvesh Agarwal, Senior Scientist, CGCRI. तालियों की गूंज से हम स्वागत करेंगे और अभिवादन करेंगे मेहमानों को आज के इस विशेष अवसर पर. डॉक्टर ललित मोहन मनोचा, इंडस्ट्रीज ऑफ डिफेंस साइंस एंड टेक्नोलॉजी से हमारे बीच हैं. आपका भी हम स्वागत करते हैं. Dr. Bhaskar Prasad Saha, Head Scientist, ARCI. We welcome you, sir. And Mr. R. Vignesh, Head Technology and Commercialization. We welcome all distinguished speakers and of this conclave. So first of all, to begin this conclave, requesting Shri Harish. Okay. We are having two different kind of conversation and seminar here. So now, with this guest, I would like to invite Mr. Roberto Tamagini here with us. Everybody put your hands together and welcome him, Mr. Roberto. Sorry. Welcome everyone. To begin this conclave for opening remarks, now I invite Shri Harish Bopalia, President, Morbi Ceramic Manufacturers Association. Sir, please.
નમસ્કાર એવરીવન. આજના આ સિરામિક કોન્ક્લેવ ફોર વિકસિત ભારત ક્વોલિટી મીટ્સ ગ્લોબલ કોમ્પિટિટિવમાં પધારેલા તમામ ભાઈઓ અને ઉદ્યોગકારોનું હું સ્વાગત કરું છું. આજના આ વાઇબ્રન્ટ ગુજરાત સૌરાષ્ટ્ર કચ્છ સમિટમાં હાજર રહેલા મહાનુભાવોનું પણ હું દિલથી સ્વાગત કરું છું. શ્રી મનોજભાઈ અરવાડિયા, પ્રમુખ શ્રી મોરબી સિરામિક એસોસિએશન, ડૉક્ટર પ્રવેશ અગ્રવાલ, સિનિયર સાયન્ટિસ્ટ, CGCRI, ડૉક્ટર લલિત મોહન મનોચા, UGC, ડૉક્ટર ભાસ્કર પ્રસાદ સાહા, મિસ્ટર વિઘ્નેશ, રોબર્ટ, આ તમામ મહાનુભાવોનું આ કોન્ક્લેવમાં હું હૃદયથી સ્વાગત કરું છું. વાઇબ્રન્ટ ગુજરાત રિજિયોનલ કોન્ફરન્સમાં સૌરાષ્ટ્ર અને કચ્છ રિજિયોનલ આપણો આ વિસ્તાર ગેમ ચેન્જર સાબિત થશે. ખાસ કરીને રાજકોટ, મોરબી, જામનગર, ભાવનગર આ બેલ્ટ છે એ મેન્યુફેક્ચરિંગ હબ, સિરામિક્સ, નાના મોટા MSME ઉદ્યોગો માટે ખૂબ જ જાણીતો છે. આ વાઇબ્રન્ટ સમિટથી નવા રોકાણકારો અને ટેકનોલોજી પાર્ટનર્સ સાથે ડાયરેક્ટ જોડાણ સ્થાપિત થશે. સ્થાનિક યુવાનો માટે રોજગાર અને સ્કિલ એપ્લિકેશન માટે નવા નવા અવસરો પ્રાપ્ત થવાના છે. પોર્ટ કનેક્ટિવિટી, ઇન્ડસ્ટ્રીયલ ઇન્ફ્રાસ્ટ્રક્ચર, ગ્રીન એનર્જી, લોજિસ્ટિકને ખૂબ જ મોટો વેગ મળશે. તો ફરીથી આ સિરામિક કોન્ક્લેવમાં પધારેલા તમામ ઉદ્યોગકારો મહાનુભાવોનું હું હૃદયથી સ્વાગત કરું છું. અસ્તુ.
થેન્ક યુ મિસ્ટર બોપલિયા, ખૂબ ખૂબ આભાર. અને આપણા સૌ માટે આનંદની વાત છે કે આજના આપણા કોન્ક્લેવમાં ઓનરેબલ યુનિયન મિનિસ્ટર શ્રી પિયુષ ગોયલજી અહીંયા પધારવાના છે. સો નાઉ ટુ મૂવ ફોરવર્ડ, ગ્લોબલ સિનારિયો એન્ડ ઓપોર્ચ્યુનિટીઝ ઇન ધ સિરામિક સેક્ટર, આ વિષય પર આપણી વચ્ચે ચર્ચા કરવા માટે નાઉ આઈ વુડ લાઇક ટુ ઇન્વાઇટ મિસ્ટર મનોજભાઈ અરવડિયા, પ્રેસિડેન્ટ વર્ટિફાઈડ ટાઇલ્સ ડિવિઝન, મોરબી સિરામિક એસોસિએશન. સર પ્લીઝ.
ગુડ મોર્નિંગ એવરીવન. મિત્રો, સૌથી પહેલાં તો આપણે જે અત્યારે વાઇબ્રન્ટ ગુજરાત રિજનલ કોન્ફરન્સ સૌરાષ્ટ્ર એન્ડ કચ્છમાં પધારેલા તમામ સ્ટેજ પર બિરાજમાન મહાનુભાવોનું હું સ્વાગત કરું છું. મારી સામે બેઠેલા દરેક ઉદ્યોગકાર મિત્રો, અધિકારીઓ, જિલ્લા અધિકારીઓ, જિલ્લા સંગઠનમાંથી અધિકારીઓ, સર્વેનું આ તકે હું સ્વાગત કરું છું. મિત્રો, સૌથી પ્રથમ તો જે આજે આપણા માનનીય વડાપ્રધાન નરેન્દ્રભાઈ મોદી સાહેબ અને આપણા ગુજરાતના મુખ્યમંત્રી શ્રી ભૂપેન્દ્રભાઈ પટેલના નેતૃત્વ હેઠળ જે આ વાઇબ્રન્ટ ગુજરાત રિજનલ સમિટ જે કચ્છ અને સૌરાષ્ટ્રનું જે આપણા રાજકોટના આંગણે જે આયોજન કરવામાં આવ્યું, એ ખરેખર આપણા બધા સૌરાષ્ટ્રવાસીઓ માટે અને સૌરાષ્ટ્રવાસીઓના દરેક નાના મોટા ઉદ્યોગકારો માટે એક ગૌરવની વાત છે. વાત કરીએ તો આપણે સૌરાષ્ટ્ર અને મોરબી, સૌરાષ્ટ્ર, કચ્છ અને મોરબી, જેમ કે ગઈકાલે જ આપણા યશસ્વી વડાપ્રધાન નરેન્દ્રભાઈ સાહેબ મોદીએ જે કીધું હતું કે જામનગર, કચ્છ અને મોરબી જે ત્રિકોણ સંગમ આવનારા સમયમાં એક દુનિયાભરમાં વિશ્વ પ્રખ્યાત થઈને આ બહાર આવશે. મિત્રો, આપણે વાત કરીએ મોરબીની. મોરબી સિરામિક સેક્ટર અત્યારે અંદાજે 800થી 1000 ફેક્ટરીઓ મોરબી સિરામિકમાં કાર્યરત છે. જે મોરબી સિરામિકનું વાર્ષિક ટર્નઓવર અંદાજે 70થી 80,000 કરોડ રૂપિયાનું ટર્નઓવર છે, જે એક ગુજરાતની અને આપણા ભારત દેશની આર્થિકમાં બહુ મોટો એક યોગદાન આપી રહ્યું છે. બીજા નંબરમાં આપણે વાત કરીએ તો કચ્છ છે. તો કચ્છની અંદર પણ આપણે ઘણી બધી ઇન્ડસ્ટ્રીઓ આવેલી છે. કચ્છની અંદર પણ આપણે વેલ્સપન છે જે નંબર 1 છે. અત્યારે કચ્છની અંદર ઘણા બધા રોકાણો આવ્યા છે કે જે કચ્છમાં અત્યારે આપણે કહીએ કે 30 મેગાવોટનો જે અત્યારે આપણો પ્રોજેક્ટ જે સોલાર પ્રોજેક્ટ આવ્યો છે. એવી અનેક યોજનાઓ આપણે કચ્છમાં અને જામનગરમાં વાત કરીએ તો જામનગરની અંદર દુનિયાની નંબર 1 રિફાઇનરી જે આવેલી છે, એ પણ આપણા માટે ગૌરવની વાત છે. બીજા નંબરમાં જામનગરનો બ્રાસપાટ ઉદ્યોગ, જેનું પણ આપણા દેશના આર્થિક વૃદ્ધિમાં ક્યાંય ને ક્યાંય મહત્તમ ભાગ ભજવી રહ્યું છે. વાત કરીએ તો રાજકોટનો એન્જિનિયરિંગ ઉદ્યોગ. મિત્રો, આપણે કલ્પના ન કરીએ, રાજકોટનો એન્જિનિયરિંગ ઉદ્યોગ એ લેવલે અત્યારે પથરાયેલો છે કે દુનિયાભરની અંદર જે રોડ ઉપર ચાલતી ગાડીઓ જે છે, કારો, લક્ઝરી કારો, એની અંદર આપણા રાજકોટના મેન્યુફેક્ચરિંગમાંથી બનેલા ઓટો પાર્ટ્સ જે છે એ સપ્લાય થાય છે. તો એ ખરેખર આપણા માટે એક બહુ મોટી ગૌરવની વાત છે. જે આજની તારીખમાં સ્પેસ સ્ટેશનમાં પણ રાજકોટમાંથી આપણા સ્પેર પાર્ટ્સ જાય છે, વિમાનમાં પણ આપણા સ્પેર પાર્ટ વપરાય છે, મેટ્રોમાં પણ આપણા સ્પાર્ટ્સ જાય છે, રેલવેમાં પણ આપણા સ્પાર્ટ્સ જાય છે. તો ખરેખર આપણા રાજકોટવાસીઓ અને સૌરાષ્ટ્રવાસીઓ માટે એક આ ગૌરવની વાત છે. ખાસ કરીએ વાત મોરબીની, તો મોરબી તો એક વિશ્વની અંદર સિરામિક સેક્ટરની અંદર નંબર 2 પર આજે ક્લસ્ટર બનીને રહ્યું છે. જે વસ્તુ જે આજને આપણને કોઈને ખબર નહોતી કે મોરબીના કોઈ માણસોએ સપનું પણ નહોતું જોયું, મોરબીના કોઈ ઉદ્યોગકારોએ આજથી 20 વર્ષ પહેલાં, હું વાત કરું છું 2004ની, કે જ્યારે મોદી સાહેબે ગેસ પાઇપલાઇન જે દાહોદથી મોરબી સુધી અંદાજે 400 કિલોમીટરની જે પાઇપલાઇન દ્વારા ગેસ સપ્લાય કરવાની જાહેરાત કરી, એના ખાતમુહૂર્ત પ્રસંગે મોદી સાહેબને આજનું ભવિષ્ય દેખાતું હતું. તો એ આપણા સૌ માટે એક ગૌરવની વાત છે કે આપણે કોઈ નહોતા જોઈ શકતા એ સપનું મોદી સાહેબે 20 વર્ષ પહેલાં જોયું હતું. અને એને સાકાર કરવા માટે મોરબીના ઉદ્યોગકારો, MSME ઉદ્યોગકારો હોય કે મોરબીના કોઈ પણ ઉદ્યોગકારો હોય, એ બધા એક સખત મહેનત, કડી મહેનત કરી, ખંભે ખંભો મિલાવી અને આજે મોરબીનું નામ વિશ્વભરની અંદર પ્રખ્યાત કર્યું છે. મોરબી આજે એક્સપોર્ટમાં વાત કરીએ તો આપણા એક્સપોર્ટ જે છે, મોદી આપણું જે મિશન છે 2047 વિકસિત ભારત વિકસિત ગુજરાત, તો વિકસિત ભારત અને વિકસિત ગુજરાત બનવા માટે આપણે વિદેશી હુંડિયામણ લાવવું પડે. તો એની અંદર પણ આપણો મહત્ત્વનો રોલ રહેલો છે. મોરબી આજે 15 થી 20 હજાર કરોડ રૂપિયાનું ખાલી ઓનલી સિરામિક પ્રોડક્ટનું એક્સપોર્ટ કરે છે. જે સિરામિક પ્રોડક્ટનું ટોટલ એક્સપોર્ટમાં 95% કોન્ટ્રીબ્યુશન જે છે એ મોરબીનું છે. તો એવી રીતે ઘણી બધી પ્રોડક્ટો જે છે મોરબીની અંદર, જેમ કે આપણે વાત કરીએ તો પોલીપેકનું પણ હબ બની ગયું છે. સિરામિક છે, સિરામિક સાથે સાથે સિરામિક સાથે જોડાયેલા અનેક રો મટીરિયલ ઉદ્યોગકારો આવે છે, જે અંદાજે 200 થી 300 નાના મોટા ઉદ્યોગો છે. અત્યારે વાત કરીએ પેપર મિલ, તો પેપર મિલ પણ આપણે આવનારા સમયનું એક હબ બનતું જાય છે. તો મોરબીની અંદર ઘણી બધી ઓપોર્ચ્યુનિટી રહેલી છે. હવે આપણે વાત કરીએ તો વાઇબ્રન્ટ, પહેલાં વાઇબ્રન્ટ જે મોદી સાહેબે સ્થાપના કરી 2003માં શરૂઆત કરી, એના થકી ગુજરાતને, ખાલી ગુજરાતને નહીં પણ આપણે આમ તો કહી શકીએ કે ઓલ ઓવર ઇન્ડિયાને બહુ મોટો વેગ મળ્યો વાઇબ્રન્ટ થકી. કેમ કે વાઇબ્રન્ટ થકી જે આંકડા તો આપણી પાસે એકચ્યુઅલ નથી, પણ 98,000 જે એમઓયુ થયા છે એ કોઈ નાની સૂની વાત નથી. એમાંથી અંદાજે 70% તો જે ગઈકાલના જે રેકોર્ડ છે, 70% તો આજે પ્લાન બધા ચાલુ થઈ ગયા છે, એમઓયુ જે થયા છે. તો અત્યારે પણ આપણે વાત કરીએ તો આજના વાઇબ્રન્ટ સમિટથી આપણને શું ફાયદો થશે? આજના વાઇબ્રન્ટથી આ જે રિજનલ કોન્ફરન્સ જે આપણે મોરબી, સૌરાષ્ટ્ર અને કચ્છમાં જે આયોજિત થઈ, એનાથી દુનિયાભરમાંથી આજે જે ડેલિગેશનો આવ્યા છે, જે ઇન્વેસ્ટરો માટે આવ્યા છે, કે જે સૌરાષ્ટ્રને ઓળખશે, સૌરાષ્ટ્ર શું છે, સૌરાષ્ટ્રને ઓળખશે, સૌરાષ્ટ્રના ધંધાદારીઓને ઓળખશે, સૌરાષ્ટ્રના ઉદ્યોગોને ઓળખશે અને સૌરાષ્ટ્રની અંદર વિપુલ પ્રમાણમાં નવા નિવેશો આવશે, એવી સંભાવનાઓ આ વાઇબ્રન્ટ થકી આપણને મળશે. તો આ વાઇબ્રન્ટનો જે કાર્યક્રમ મોદી સાહેબે જે આપણે અહીંયા રાજકોટ અને મોરબી કચ્છમાં જે ખરેખર એક આપણને આગળના સમયમાં નવા ટ્રેક ઉપર અને નવી દિશા બતાવશે, એવું સાબિત થશે. અસ્તુ. ભારત માતા કી જય. વંદે માતરમ. જય હિન્દ.
થેન્ક યુ સો મચ મનોજભાઈ, ખૂબ ખૂબ આભાર. ઘણી બધી દિશાઓ જે ખુલી રહી છે પ્રગતિના માર્ગ ઉપર સૌરાષ્ટ્ર, કાઠિયાવાડ અને કચ્છ પંથકમાં, એની વિશેષ રૂપે આપે વાત કરી. નાવ આઈ વુડ લાઇક ટુ ઇન્વાઇટ ડૉક્ટર પરવેશ અગ્રવાલ, સિનિયર સાયન્ટિસ્ટ CGCRI, to discuss Ceramic Cluster of India Gujarat Vision 2047.
नमस्कार। मैं सबसे पहले तो गुजरात गवर्नमेंट में इंडस्ट्रीज़ कमिश्नरेट से इंडस्ट्री कमिश्नर श्री स्वरूप पी जी का बहुत बहुत आभारी हूँ। उन्होंने मुझे ये मौका दिया कि मैं आपके सामने आकर सेरामिक्स के ऊपर कुछ बात करूँ। मेरा नाम डॉक्टर परवेश अग्रवाल है। मैंने बीटेक इन सेरामिक्स फ्रॉम IIT BHU से किया है और PhD मिनरल इंजीनियरिंग में IIT SM धनबाद से किया था और मैं इस समय साइंटिस्ट इंचार्ज CGCRI नरोडा सेंटर के पद पे कार्यरत हूँ। हमारा CGCRI नरोडा सेंटर जो है ये सेंट्रल ग्लास एंड सेरामिक रिसर्च इंस्टीट्यूट जो CSIR की एक मेन लैब है उसका एक्सटेंशन सेंटर है नरोडा में। और ये सेंटर पिछले 50 साल से सेरामिक इंडस्ट्री की बेनिफिट के लिए काम कर रहा है और ये सेंटर एक ISO 9001:2015 सर्टिफाइड R&D सेंटर है और इसकी स्थापना CSIR और गुजरात गवर्नमेंट के जॉइंट सपोर्ट से हुई थी। इसलिए हमारा जो रिकरिंग एक्सपेंडिचर है ये शेयर्ड बाई गवर्नमेंट ऑफ गुजरात है। हमारा सेंटर जो है ये R&D प्रोजेक्ट्स सेरामिक के क्षेत्र में R&D प्रोजेक्ट्स करता है और टेक्निकल प्रॉब्लम सॉल्विंग के लिए इंडस्ट्रीज़ को सपोर्ट करता है। We provide testing, certification, technical troubleshooting services to the industry, and also we impart training for human resource development. In this presentation, I will try to bring out some business opportunities available in traditional ceramic fields, which is required for our dream of Viksit Bharat 2047. As Manoj ji right now said, that traditional ceramic industry in Gujarat is growing to any extent, and the biggest ceramic industry in the Gujarat is dust press ceramic tiles, which is situated in Morbi, the cluster, ceramic tile cluster situated in Morbi. This is the largest, second largest in the world cluster, and simultaneously we have vitreous China sanitary ware industry also there in Morbi and Thangar, this area. So these two industries contribute the maximum portion of the traditional ceramic products being manufactured in our country. Other products which are also coming up in this Gujarat are refractory bricks, castable, ramming mass and other refractory products, porcelain insulator, LT and HT insulators, then crockery and tableware sector is also growing up, technical ceramics, stay-tight, high alumina porcelain, acid-proof tiles and liners, and along with these manufacturing industries, we have raw material supplies, mining and washery industries are there, than clay, kaolin, plastic clay, bauxite, bentonite, silica, sand, etc. All these minerals are available in Gujarat and these are being marketed by the companies. So, we will now focus on ceramic, traditional ceramic manufacturing in area of tiles and sanitary ware, because these are the two largest sectors. My remaining presentation will focus on these two areas only. So, the growth of ceramic industry, especially this dust press ceramic tile industry in Gujarat, is due to locally available clays and suitable raw materials available here, and other raw materials such as feldspar, quartz, dolomite, wollastonite, calcite, talc, etc. are coming from neighboring Rajasthan state, which is quite nearby, so transportation cost is affordable. Then extremely high entrepreneurship spirit of the people here in Gujarat, and good understanding and cooperation among the entrepreneurs on technical aspects of production. These two aspects are growth drivers for this unprecedented growth of ceramic industries in this region, and the mechanism is the cloning of industry. And large domestic market is present here, proximity to the ports is here, uninterrupted supply of fuel, Manoj ji just now told, is there. Then presence of world leaders in tile production machinery locally, because the cluster has grown so much that all the big machinery manufacturers have opened their shop in the Morbi, so that they can serve the industry, get the market here. And the weakness, if we discuss, the fast depletion of good raw materials due to high consumption of production. These both the industries, tiles and sanitary, we are consuming very high amount of raw materials. Then we have insufficient R&D on raw material standardization and their judicial use. Then insufficient R&D on plant and machinery as well. Then price competition among the manufacturers due to very high volume of production. This is a weakness which the industrialist has to realize. Then dependence on imports, high plant and machinery particularly, we have to import plant and machinery. Then insufficient infrastructure to cope up with growing production volumes. These are the aspects for dust press ceramic tiles. Similarly, for sanitary ware industry, the strength area is the sanitary ware from Gujarat is considered to be the most cost competitive worldwide. Nobody in the world can supply sanitary ware in the prices which we are supplying. Then availability of than clay at economical cost. Than clay is the major raw material, clay material, which is required for making sanitary ware slip casting, sanitary ware slip. So this is the one of the finest clay available in India for making of casting slip. So that is an advantage. Then technically the products meet Indian or foreign standard specification. We are meeting all the IS specifications as well international specification as far as the technical part is concerned. But technical and aesthetics, these two are different things. So we are lacking in aesthetics, but complying the technical requirements. Then designing, the weak areas are designing, model development and mold making. These are the weakest area of our Indian sanitary ware manufacturing. Use of non-standard crude clays for production, this is also a weak area. Energy usage are higher. So insufficient research and development initiative at the industry level, these are the weak areas. So having said these, we have zeroed upon 5 strategic focus areas where traditional ceramics manufacturing should focus to realize the goal of Viksit Bharat 2047. First is raw material consumables, second is plaster of Paris and resin mold for slip casting sanitary ware, third is energy, or fourth is staff welfare, and fifth is infrastructure. So in further slides, I will be discussing one by one these areas. First, ceramic raw materials. We know with continuously increasing production, the availability of suitable quality raw material will reduce gradually. The demand will grow, but the supply will reduce. To tackle this situation, strategies both at field level and the policy level to be adopted to ensure long-term availability of raw materials for this high volume industry. So we know that Gujarat hosts kaolin, ball clay, fire clay, than clay, feldspar, quartz, silica sand, limestone, sandstone, bentonite and black trap, etc., which are backbone for ceramic industries, these raw materials. And specifically talking about Thangad region, there than clay is available, white clay is available, red clay, sandstone, sand, limestone, etc. These raw materials are available. But further talking about the than clay, which is required for sanitary, essentially required for sanitary ware production. So this than clay occurs with the lignite. Since the than clay underpins the sanitary ware industry, but it is co-located with lignite, so unsystematic lignite mining is causing the clay loss. So government intervention is needed for responsible mining so that this clay, than clay, which is essential material, can be preserved. Then since this is being wasted by lignite miners, so we have to develop technologies, R&D, to recover wasted than clay. Then we have to upgrade. Always there is in the nature there are raw materials which are of suitable quality and raw materials of second grade quality. So we should have R&D on upgrade second grade minerals. Second grade deposits are left as a waste at mine sites. So research on beneficiation and upgrading of them for making them suitable for manufacturing sanitary ware is required. Then since the raw material requirement very high, so we have to explore alternative raw materials, put R&D on substitutes using secondary minerals, industrial waste and byproducts for ceramic tile production. So these are the challenges. What we have to, how we can overcome these challenges. So we need to have a systematic approach for overcoming these challenges. So assess regional mineral wealth. We have to conduct comprehensive resource mapping and reserve estimation of ceramic minerals in Gujarat and elsewhere in India, and prepare systematic mining plans, develop long-term sustainable mine plans to secure continuous supply for traditional ceramic industries, and scale up organized mining. As such, we are not doing this on a greater scale. So promote large scale systematic excavation of raw materials and replace ad hoc practices. So we have benchmark global suppliers. We know Emery's, Sibelco, Quartzwork and Thiel Kaolinite. These are the companies, multinational companies, global companies which are providing, which are supplying standard grades raw material to the ceramic industries worldwide, and they are maintaining this business for decades, like 50 years or 100 years. So they are able to supply similar grades of raw materials to the ceramic industries. So how they are doing that? that is to be studied, and establish domestic supply organization, encourage formation of a specialized producer to supply standardized ceramic raw grades. So develop this. For doing this work, we have to develop beneficiation flow sheets, create process routes to upgrade low grade and mixed minerals for manufacturing use, set up beneficiation units, establish regional upgrading facilities to improve quality and reduce waste, then prospect new source nationwide, identify and develop additional raw material deposits to secure clusters like Morbi and Thangad, and conserve domestic resources. This is one of the important aspect. The government should restrict export of ceramic raw materials to preserve local availability and support downstream industries. So this is in the raw materials. Now coming to consumables. Consumable is another area where strategic focus is required. We know the tile has two parts. One is lower body and other is the upper surface. The lower body is manufactured by using clay, etc. raw materials, and the upper surface is produced by digital printing technology. So import dependence is heavy on these surface chemicals, digital printing, etc. We use imported frites, glazes, compounds, and inks, etc., which are generally coming from Italy, Spain, or China. So we need a strategically develop indigenous materials for tile surface production, and we should make R&D on frites, glazes, suspension kaolin, printing compounds, inks, and as well as functional additives such as anti-skid chemicals, nanochemicals for enhanced surface properties, with the objective to reduce import dependence and strengthen domestic supply chain. Another area which is mostly not looked upon is the water. So good casting slip for sanitary ware requires TDS of less than 200 ppm water. Groundwater TDS in Thangad and Morbi area is typically around 700 ppm or higher. So manufacturers use RO system that waste about 70% of input water. So we need to develop water treatment solutions that minimize waste and provide cost-effective low TDS water for this manufacturing. Another area is plaster of Paris mold making technology, which is essentially required for sanitary ware manufacturing. So continuous development of new shapes and designs of sanitary ware product is the most important area where sanitary ware manufacturers are looking at. So we need to, in this area, at present the needs of the factory are fulfilled by mold makers or molders which are individually working for the any industry. So establishment of a design development center equipped with modern facilities such as 3D printers, numeric control machines, and designing software are required for providing training to these individual molders, mold makers, as well as to train the manpower, human resource development, so that we can have more number of molders, modelers in this area. So we need a training institute. Then manufacturing of different grades of POP. Plaster of Paris in India, we are making normally 1 or 2 grades of plaster of Paris, whereas the requirement, it's according to its application, there are type of casting processes such as battery casting, pressure casting, model making, like POP is also employed in model making, capillary casting, ramp pressing, case making, etc. applications. These all applications require different type of POP grades. So we need to have technology for making POP suitable to the needs of these applications. Another area is pressure casting technology. Pressure casting technology is not too much, it's not adopted in our country to a great significant extent. It gives very high productivity, it requires less space and delivers significantly higher output than battery and bench casting, which is the traditional practice in sanitary ware industry. Resin mold has an advantage because it is made by specialized resin, and it can produce up to 25,000 castings. 25,000 castings per mold you can have, whereas in traditional way POP molds we get only 90 to 100 pieces per mold. So this is a very high productivity item, but the challenge is that how to manufacture this high quality resin mold. It is very specialized technology and it's not available in our country. And if we want to buy this resin mold from Italy or Spain, so they are charging very prohibitive prices. You have to pay about 8 to 10 lakhs rupees for a single mold, so which is not affordable. So we need to acquire this technology to manufacture high pressure casting machine and resin molds domestically, and we need to commercialize this technology to produce and sell machines and molds to sanitary ware producers to reduce import dependence and lower cost. Other machineries which are important to our traditional ceramic manufacturing are kilns, roller kilns, tunnel kilns for sanitary ware, hydraulic presses for tiles, continuous press for slab tiles, digital printers. All these machines are usually imported from different countries. So these are not manufactured in India. So we have to, like machinery manufacturers have to come up and make these machines so that we are self-sustainable here. And another requirement is alumina rollers, ball mill liners and grinding media, which we are producing in India, but only thing is that they are not cost effective. We have to develop indigenous or acquire imported cost competitive technology for manufacturing high alumina grinding media to match lower priced Chinese imports, addressing the high cost and limited availability of suitable bauxite from Kutch. So we have to work on this. Alumina means cost effective alumina materials. Another area, fuel, is also very important because fuel makes the about 40% cost of the production is the firing cost. So fuel is a major component of production and cost and must be reduced. So because it is constituting 40% of the production cost, that means there is a huge scope for development. So kiln efficiency can be improved through technology development, energy audits and R&D on alternate fuels, low energy bodies and glazes. So lightweight kiln cars and durable kiln furniture at affordable prices can help save the fuel. R&D should address radiation shielding, minimizing chimney losses, efficient fuel burning, heat recuperation and reducing heat emitting surfaces. So how to do this, all these objectives, how we can meet is the energy audits of kiln and training entrepreneurs on energy efficiency are essential. If we work in this area, we can definitely reduce the cost of production, and indigenous development of fast firing kilns along with compatible bodies and glazes will lower the production cost. So durable and along with this fuel, we also require kiln furniture to set up the material in the kilns for firing. So durable, affordable refractory plates made up of silicon carbide or corderite are needed for loading sanitary ware, which is fired at 1220 degrees centigrade in 22 to 24-hour cycles. Currently, we are depending on imported bats from Spain, which is unsustainable, and our Indian corderite plates which are used show bending after a few cycles. So this is a problem. That is why we are importing all materials. Then common kiln furniture materials include corderite, corderite mullite, silicon carbide and nitride bonded silicon carbide. Silicon carbide offers a longer life, but it is very expensive and is not available in quantity. Then develop. So we have to develop cheaper, stronger refractory kiln furniture suitable for sanitary ware loading, and we have to undertake R&D to develop lower cost silicon carbide plates and kiln furniture with extended service life. So all these R&D interventions, who will steer, who will drive this research and development? So for that we require to establish a well-equipped testing laboratory in Morbi with instruments such as particle size analyzer, TGDTA, XRD and XRF, etc., to meet the R&D testing and certification needs of over 1,000 local ceramic industries. Or we may consider a CGCRI outreach center in Morbi itself. Otherwise, another option is we can strengthen CGCRI Naroda Center in terms of manpower and facilities to fulfill the demand of traditional ceramic industries. What this laboratory will do, if we establish a laboratory, what are our expectation from this laboratory? It will pursue international collaboration with leading laboratories in Spain, Italy and China and other European countries for joint R&D on technologies relevant to sanitary ware and tiles to accelerate development and technology transfer to Indian industries. This is the fastest way to get a technology for our use. Then train laboratory professionals in Morbi, Thangad on operation and maintenance of sophisticated equipments, testing and in-house R&D activities. Then a skill development program for entrepreneurs, professionals, students, workers and consultants. These need to continue, and tailor-made training to address evolving industry needs is always required, which we of course are doing. Then support industry preparedness for the forthcoming quality control order that will strengthen enforcement of Indian standards and make ISI certification mandatory for ceramic products. In this initiative, we will be providing guidance, testing support and capacity building to facilitate compliance. This laboratory can do, and we know no industry can survive without labor and without manpower. So we need to have some staff welfare activities. For welfare of large workforce working in the tile and allied industries include labor, contractor and supervisors, workers, common residential facilities with drinking water, electricity and sanitation, schools, hospitals, child daycare centers, local transport, recreation center, etc. to be established. This is the area where government as well as the industry associations have to look at. Also in the area of infrastructure, I want to say that railway being a cheaper mode of transport, the infrastructure for maximization of transportation of raw materials and finished goods through container trains will help to reduce the cost of production as well as selling prices. As the production volumes are increasing, the traffic of trucks is increasing by its double. Simultaneous increase in road network is needed. All weather roads of 60 tons plus capacity in the industrial area, including inside roads, broadening of roads to handle ever increasing truck traffic, establishment of transport nagar if needed, these things to be done. Then sea routes for transportation of tiles from Gujarat to other parts of country, India, to be made available. These are the infrastructure requirements. So concluding my talk, I have zeroed upon 8 numbers of opportunities where our entrepreneurs can do something to get business. Is establishing a large scale manufacturing and supply of standardized ceramic raw material on the lines of global players like Sibelco, Sibelco, etc. offer immense potential to meet industry demand and reduce reliance on imports. Then large quantities of low TDS water are required in slip house of ceramic industries. So meeting this demand presents a significant business opportunity. Then consumables like fritz, glazes, kaolin suspension, printing, inks and nanochemicals offer major business opportunity. Manufacturing specialized grade of POP for diverse casting application offer a profitable niche in ceramic and sanitary ware industry. Then developing and marketing high pressure casting machines along with resin molds creates a strong business avenue by catering directly to the sanitary ware producers. Indigenous production of high alumina rollers, ball mills, liners and media using local raw material is a good business opportunity. Providing kiln energy audits and entrepreneurs training on energy efficiency creates a valuable service market, helping industries cut cost while promoting sustainable practices. And supplying high quality long lasting kiln furniture offers a strong potential to meet the growing demand of sanitary ware industry. That is all, sir. Thank you for patient hearing. Thank you so much.
Thank you, Mr. Agarwal. It is a very brief and detailed presentation. It is very much needful to all of us. Thank you so much. Now, on advanced ceramics and their role in decarbonization, इस subject पे बात करने के लिए I would like to invite Dr. Lalit Mohan Manocha. Everybody put hands together and let's invite him. Institution of Defense Science and Technology, Mr. Manocha.
ગુડ મોર્નિંગ એવરીવન. બધાને હું પણ સ્વાગત કરું છું અને સ્પેશલી ડૉક્ટર શ્રીમાલી and the government of Gujarat who has invited me. I was a bit surprised because I belong to Delhi region. But Gujarat is my first home because I spent 25 years in Gujarat. And when I was in Gujarat at Sardar Patel University as professor and head of the Department of Material Science, my concern was, of course, towards ceramics and advanced materials, especially advanced ceramics. I think it's because of that one that I have been asked to come over here. I'm thankful to the dignitaries on the dais, especially Harish Bhai, Manoj Bhai, and Vignesh Bhai, that they have talked about the vibrant Gujarat. What I have made the presentation is different. So, because I was a professor, the professor always deviates from his talk and all that thing, and that is what I'm doing. So, please, you will excuse me for that. So, I will spend few minutes before presenting my talk on this topic that I am concerned. I am pained. I would say Manoj Bhai, Harish Bhai, and Vignesh Bhai, I am really pained today that I spent 25, I came to Gujarat in 1990, and still since then I have been requesting the ceramic manufacturers here. Even I approached Mr. Somani also, we had a very long talk and all that thing, that you have to come little bit from this core ceramics to advanced ceramics. You know, we have Honorable Prime Minister Narendra Bhai, who is very much concerned about defense, is spending lot of money he is allocating for defense. And his main area is Viksit Bharat. Okay, Viksit Bharat. And I'm pained to say that during my life, I have made China Viksit. I was consultant to China, consultant to South Korea, consultant to US, all the countries. I made them Viksit in the area of advanced ceramics and composites, but I could not do anything for Gujarat. So my first request to you over here is, please, we have still 22 years to vibrant Gujarat, 2047. Please, little bit expand, come to the area of advanced ceramics and composites, especially for defense and space application. I'm very happy when Manoj Bhai he said that we are supplying some parts to space and all that thing. But what kind of space? What kind of parts we are supplying? Very minimal, small one. Come out of it. I must say I'm concerned sometimes that now even people from Gujarat are establishing big concern, big organization, etc. in Telangana. You will excuse me, Mr. Saab, in Hyderabad and Dangalan, where I am again a consultant. They ask me, and I have to do it. They are people from Gujarat, okay, from Surat and other places. They have come out with big industries making high performance ceramic matrix composites for defense and all that things. But what about you people? Please, please, this is my humble request. I'm gray hat. So please, this is my humble request to all of you. Please extend. There's lot allocation made by the, we are very lucky to have the Prime Minister who has got a vision. He is also from Gujarat and he has got a vision. So make use of his vision, come out of that. Please expand your ceramics to advanced ceramics. You will agree with me, Dr. Agarwal. Okay, so that was my first concern. I said this thing in Rajkot in 2023 also. I made the presentation. Okay, as I told, I am the first professor who has been inducted into the Institute of Materials, Institute of Defense Scientists and Technologies, and our aim is to expand, to work and promote the research development, indigenous development of the ceramic matrix composite and so on for our missile systems and for our LCA and all that things. You know, I don't know whether you know it or not, the brake pads, the initial work on brake pads for LCA aircraft was done in Vijayanagar. Okay. Well, so these things we had started, but you have to please help and do it further. Okay. I hope you won't mind my initial remarks. And the another thing that is concerns to me is, which again comes under the advanced ceramics and the, of course for the ceramic industry, is there are two areas which must be considered. Of course, Dr. Agarwal has pointed out some of the concerns about this one, is the energy. Okay, so you have to develop the methodology to decrease the energy consumption by the ways that Dr. Agarwal has said, or you all know it, but we have to concentrate on that one, give more emphasis on that, and also the decarbonization, because you know, all of that, you know, Delhi is suffering from high this pollution, etc. And that pollution from Delhi will come to Gujarat if you are not concerned about that. So therefore, we need to concentrate on these two aspects. One is decreasing the energy consumption and also the decarbonization. So I will say, over the last 2-3 days, I tried to make certain things which I will present over here. I hope it will be of some use to you, or not use, but I hope that you will carry the message and work on it, the young people. Okay? Yeah, thank you. Yeah, what I said is energy demand is a big concern. And what are the ways out of this one? We know the energy is major requirement for existence of the human being, for existence of everything. So therefore, we have to work on the various aspects which associated with that one, and a major concern has been protecting environment during energy production as well as utilization. Production as well as utilization, both these the pollution comes out. So we have to work in both the areas where ceramic can play a big role. This is what I want to say. Okay, okay, that is what we call the greenhouse gas emission, which, as I said, that ceramic play a major role in energy sector, both production and utilization. Okay, here, where to go? Okay, thank you. Yeah, as I said, that the major concern of the environment is carbon dioxide. CO2 is a greenhouse gas that can absorb heat. It can absorb heat from the sun. Of course, there are other gases also which absorb heat from the sun, the nitrogen, etc., and oxygen, and ammonia, and all kind of things. But they absorb and release it immediately, whereas carbon dioxide, it absorbs and releases it gradually. So means that the environment effect is over a longer time. So that is the concern of CO2, and CO2 also gets easily absorbed in the ocean, and where it reacts with water molecules and produces carbonic acid, which lowers the pH of the ocean, and that may be of concern to the people in Gujarat, which are around the say sea area, because that the ground, because it will ultimately go to the groundwater. So therefore, the groundwater is getting affected, and that groundwater is being used by the people in around that area in Gujarat, as well as by the industry. So therefore, when we protect this, the ocean water, we are protecting the groundwater, which is affecting said the civilization as well as the industry. So therefore, the solution to this one is removing or decreasing carbon dioxide, that is a decarbonization. Okay. So what is decarbonization? Decarbonization is the systematic reduction and eventual elimination of CO2 and other greenhouse gas emission while maintaining the performance. That's very important. We have to maintain the performance, reliability, and economic viability. Am I going with this one? No. No. Oh. Okay. Okay. Now. Yes, that's okay. Yeah. So decarbonization is a systematic reduction and eventual elimination of CO2 and other greenhouse gas emissions while maintaining performance, reliability, and economic viability. This is also very important that we have to maintain this one. And this concerns, as I said, energy generation. Energy generation, we are using mostly the fossil fuels. So in these fossil fuels, combustion of fossil fuels release a lot of carbon dioxide. So we have to see that we can decrease the combustion of fossil fuels, or have the alternative sources of energy. And the industrial processes for various sectors, starting from the metallurgy, the chemical, steel, refining, etc., which are all in Gujarat. And these demand materials capable of operating at high temperature and aggressive environment. So we have to keep in mind that all these processes, they need high temperature. We cannot decrease the high temperature requirement for metallurgy. So that has to be. And ceramic also, then, and so on. And transportation, and also the materials production, as I said, glass, ceramics, etc. All these, they require the energy and so on. Okay, this is what is the major concern for, and we have to do the decarbonization. How the ceramics are important for decarbonization, what is their role in decarbonization, how they compare, for how they become more important for decarbonization, because ceramics provide unique thermochemical, electrochemical, and structural properties essential for next generation low carbon technology. Ceramics are the basic and the important materials which can do this. And they have got exceptional thermal stability, enabling sustained operation above the 600 degree centigrade to 2000 degree centigrade. So therefore, ceramics are essential for certain operations. High resistance to oxidation, reduction, corrosion, and carbon deposition. Favorable functional properties including ionic conductivity, mixed ionic electronic conduction, and catalytic activity. And they are compatible with dense porous composite and multi-layer architecture. That's why we use cup. for tea because it is compatible with tea. It doesn't absorb tea, and the tea will be used for us. So that's why there are, ceramic have got many plus points. That's why we need ceramics. But what is required to achieve decarbonization is electrification of energy-intensive processes using low-carbon electricity. That is very important, and some of the aspects have been taken up by Dr. Agarwal. We have to see alternative fossil-derived feedstocks. A lot can be discussed upon this one. There are experts who can give more, information about that one. Green hydrogen, because we know that there are, I will come to it later on, there are 3 now sources of the energy, which I will come to later on. Therefore, the green hydrogen is the future for the country. Green hydrogen is the future of our country, and I hope you will talk about that one. And then it's a carbon capture, utilization and storage for unavoidable process emissions, again can be done by ceramic. How I will come to that later on. High efficiency, high temperature materials capable of operating under extreme thermal, chemical and electrochemical conditions. System integration and circularity, minimizing energy losses and material footprints. So these are the some of the approaches for decarbonization. As I said, the first one is energy. So everyone, we have been talking about it for a long time on renewable energy. And among the renewable energy sources are the solar energy, wind energy, and green hydrogen. And well, I'm very happy that Gujarat has been doing in all the aspects. Solar energy, we have the whole solar panels. Modi Sahab has loaded the whole canal with the solar cells. It's very important and it's very encouraging. Wind energy, we have got windmills, and yesterday someone was telling that we are in Gujarat, we are trying now to install wind energy mills offshore, not onshore, but offshore. Windmills are also in the plan, and the green hydrogen. This is, I think, not very much taken up by Gujarat. So this is one area that you please take it up. I'm very happy that even the logo of Vibrant Gujarat, the first page of Vibrant Gujarat, has the figures of the solar panels, wind panels, and green hydrogen to some extent. So therefore, this has to be, I would say, encouraged. And for that one, we have to develop materials with desired architecture, surface morphology, synergeticity, chemical compositions, and active sites of electrocatalyst. So this is an area where ceramic can little bit contribute, and that is with the help of the university systems in Gujarat. Many universities in Gujarat are working in this area. What you have to do is you have to help them to work more in that one, get joint projects with the universities or with CGCRI, and innovate these materials. One example of this one is tin oxide. Like tin oxide, again, it's a ceramic, no? So you have to work not only in the traditional ceramic, some outside your domain. Like tin oxide anodes help electrochemically produce silicon with less energy, and this silicon is used for silicon solar cell. So what you are doing is you are helping in both ways. You are using your ceramics, producing silicon. The silicon is used for solar cells. So that way, the ceramic industry is helping, has got a major role in the renewable energy. So that is, of course, been doing something, but then it's more important that you concentrate on more on that one. Okay. Ceramic are also used for decarbonization technologies. There is extensive global activity in decarbonization technology, and ceramic materials have a significant impact on many of these technologies. As I said, hydrogen economy, so the green energy. Please think in these terms. Carbon capture and utilization, because this carbon dioxide can be captured by the ceramic. Ceramic membranes can be developed. Ceramic membranes can be used for separating carbon dioxide, CO2 from flue gases, and also there is an example where the carbon dioxide which is emitted from the ceramic industry or some other industries can be dissolved into water, and this carbon dioxide dissolved water is then sprayed onto basalt rock, and when you spray on basalt rock, you make carbonates, white powder, carbonate, which is used for ceramic industry. So like that one, you are starting with ceramic, absorbing carbon dioxide, putting it water, and putting back to basalt rock, and again getting the raw material from the basalt rocks, making use of the basalt rocks, and using the ceramic industry. So that way, I want to say it's a cycle. So you can think of that. There are many things like that one. The thermal management, ceramics are excellent material for thermal management. Also, the ceramics are the number one as a catalyst and used for filtration, the wastewater filtration, etc. These are ceramic membranes and RO. All the ROs use the ceramics. So these are, so ceramic play a major role in the decarbonization. And the other one is hybrid. This is ceramics itself, but then you can make hybrid ceramics, and this also can be. This also are very important. And nano ceramics, hybrid ceramics, and nano ceramics, which are again are very helpful, essential for energy storage, energy management, and decarbonization. An example is perovskites are widely researched defect thermal tolerant absorber material for solar cell application, the perovskites. And these perovskites with CS dispersion in the layers is more useful than the perovskite as such. So that way it makes the hybrid material. Hybrid nanomaterial like boron nitride, coated titanium, nanotubes. So these are some advanced ones, which again are very important for the thermal management and for the decarbonization. And another area is the metal organic frameworks. So these are the areas which are being pursued by some of the organizations, some of the universities in Gujarat. You have to encourage them. You have to little bit go to faster to that one. Okay, decarbonization and ceramics, as I said, these are important materials for fuel switching, energy efficiency, innovation, process electrifications, and so on. Well, I will present some case studies where ceramics are used for decarbonization. The one is solid oxide electrolysis cell. Electrolytes like YSZD and SCZD provide higher oxygen ion conductivity at elevated temperatures. These are, I don't know, more scientific aspects of that one. So, but the thing is that the solid oxide electrolysis cells, which are again based on ceramics, where again ceramic base plays a major role, are very, I would say, useful, are essential, and say for the, I would say, Viksit Bharat programs and the vibrant Gujarat and so on. Well, okay. The another example is oxygen transport membrane. So, as I said, this perovskite based the ceramics, which they enable simultaneous oxygen ion and electron transport, which is again very important and essential for the current industries as well as for the environment. The selective oxygen permeation driven by chemical potential gradients without extreme circuitry, operating temperature also very high, Therefore, the energy saving of 35 to 50% can be say made compared to the cryogenic air separation units, integration with oxy-fuels combustion, and so on. This is another case study where, as I said, that calcium-based ceramic sorbents, calcium oxide, calcium carbonate, these are used for high temperature carbon dioxide capture. So we can use, the ceramics can be used for carbon dioxide capture as well as for converting carbon dioxide to the useful materials. The dual function materials integrate capture and catalytic conversion within a single ceramic matrix, high cycle stability over repeated carbonization, calcination cycles, reduced system complexity, and lower overall energy penalty compared to the standalone capture units. So these are some of the things which can be done. The carbon dioxide derived carbon ceramic composites is another very important area which which is value added ceramic through electrochemical, thermochemical, and photochemical means. The chemical stability of CO2 is quite an important, but it results to either partial reduction of CO2 to fuels. So you can capture CO2 and then reduce it to the fuels. Well, these are some of the examples, but there are many more things that can be done where ceramic industry has got a major role to play. So my only humble request to you is that please, over the next 20 years, we have still 2047, we have got 22 years. The ceramic industry, people should not, outside of Gujarat, should not just say, well, oh, Gujarat, okay, well, they can make cups, they can make tiles, they can make this, come out of it. Have your name in advanced ceramics and contribute to the defense technology. There's a lot of potential, a lot of money in the defense. If you want, I can help you. Because I'm in many of the committees of defense, say allocating funds and recognizing the projects. If you wish, I can help. I can help getting you the projects from the government, from DRDO, to make high performance ceramics for defense applications, for space applications, for the future technology. So, well, in essence, ceramics are both a source of emissions due to high temperature production. So here again, you can decrease the temperature of ceramic processing. When you decrease the temperature of ceramic processing by, I would say, hot pressing and that kind of things, you are, say, decarbonization, you are helping in decarbonization. And a vital tool for achieving net zero through innovative applications and cleaner manufacturing. So there are some of the future directives. I think I'm running out of time. I will thank you all, and I hope next time when I come to Gujarat, I was 25 years in Gujarat. I've moved to now Delhi, but when I come next year, when I come next time to Gujarat, I will be very happy that if I find that my coming over here has been useful and you people have got and have formulated some projects where you can enter the advanced ceramics and advanced ceramic composites for defense application. I'm more concerned about the defense application. I would tell you one thing. If you, I would say, have 2 minutes. If you can listen to me, the old man, 2 minutes. In 1972, when I started my research, okay, I was started my PhD in 1972 in NPL, National Physical Laboratory. I was told, when I came, I was told that there is someone with the name Abdul Kalam. There's someone with the name Abdul Kalam in Vikram Sarabhai Space Center, VSSC. He wants to make a rocket, but we did not have at that time, we didn't have the polymers in the country. No polymers, no glass fiber, nothing, no composites. And he wanted to make composites for the rockets. So he said, I want to make carbon fiber, I want to make rockets I want to make fibers and polymers to make rockets. So the government gave program to make glass fiber with CGCRI and IIT Kanpur, carbon fiber in NPL, and we didn't have any publication. It was banned. It was banned. No one in the world can publish paper on carbon fiber. And when I joined, I was asked, can you make carbon fiber? I said, yes. And my boss asked me, do you know carbon? I said, no. He said, how will you make? Well, I will try. And we were the first. We were the first in Asia after Japan, because Japan had developed the technology to make carbon fiber. So that is how I started interaction with Dr. Kalam. And then when I submitted my PhD, I was invited by US as a lecturer, by UK, as well as by Germany. But I said, okay, I will go to Germany, work for a few years and come back, because I am devoted to this country, to defense. Then Kalam moved to defense, moved to DRDL. So he again encouraged Kota Indira, he said, we want to make carbon-carbon. But I'm telling you, we started from AB initio, and now we have the technology. We produce our own carbon-carbon composite brake disc for all our fighter aircrafts. So we have the capabilities. The only thing is, the people like you have to encourage. You have to encourage the young people working in the university, in the CSIR labs, and we will do it. And who will get the benefit? You will get the benefit. You will get the name. You will get the export market. You will get the export market. You will get the money also. Everything. With this humble request, thank you very much.
Thank you, Dr. Manocha, for very sensible suggestions and your presentation. Thank you so much. Now, આપણા બધાની વચ્ચે માનનીય યુનિયન મિનિસ્ટર શ્રી પિયુષ પટેલ સાહેબ પણ પધારવાના છે. શ્રી જીતુભાઈ વાઘાણી પણ તેમનો સમય આપણને ફાળવશે. થોડી જ ક્ષણોમાં તે લોકો અહીં આવી શકે છે. Now I would like to invite Dr. Bhaskar Prasad Saha, Head Scientist, ARCI for powder. Yes, Mr. Kiran Jhaveri, Honorable Collector of Rajkot, we welcome you, sir. તાળીઓથી આપણે સ્વાગત કરીશું માનનીય કલેક્ટર સાહેબનું. કિરણ ઝવેરી સર. માફ કરશો, કલેક્ટર મોરબી. મોરબી ઇઝ અ સેરામિક હબ અને મોરબીના માન્ય કલેક્ટર શ્રી આપણી વચ્ચે છે. ખૂબ ખૂબ સ્વાગત છે આપનું. Now inviting our another dignitary, Dr. Bhaskar Prasad Saha, for his presentation and speech.
नहीं बंद करना है ये बंद करना ये मेरा है बंद करो पेन ड्राइव में हाँ ये Good morning, the dignitaries on the dais, Collector Sir Mr. Kiranji, and the dignitaries in the audience. This is Dr. B.P. Saha, Bhaskar Prasad Saha. I give a little brief about me. I did my BTech in ceramic engineering from College of Ceramic Technology, Kolkata University. Subsequently, I did my my MTech from IIT Kanpur, followed by my PhD from Indian Institute of Science, Bangalore. Before I go to my presentation, I would like to extend my sincere thanks to the commissioner, industry commissioner, P. Swaroop, and the organizing committee members. And I mean, in my last presentations, the stalwart of advanced ceramics, Professor Manoj sir, told that not much of advanced ceramics works for strategic applications have been done. But I promise, sir, each and every slide of my presentation will have strategic applications for societal applications, energy applications. So let me start my presentation. So here are the products what I am going to speak about. You can see the pictorial depictions of my presentation products what I am going to present. So I will present about space mirror materials, which is made of low expansion glass ceramics, which is used by ISRO. Then I'll talk about this laser gyroscope, which is used in missiles. I'll talk about silicon carbide products, which is again used for space mirror applications, armor tiles, molten metal filtrations, then many other applications in subsequent slides I am going to present. Then I will talk about transparent ceramics, which is the worst area, and you will see what are the uses. Right side of the slide, on the top you will find the equipment required for processing of the advanced ceramics. So in ceramic industries, it's not the product. A lot of ancillaries are involved in that. Equipment, raw materials, and testing characterization facilities. So before I go to my presentation, I would like to tune with the tone of our Honorable Prime Minister Narendra Modi sir, and eminent scientist, eminent entrepreneur Mukesh Ambani sir, who told that the time has come due to this geopolitical situation. We may be deprived of getting so many products and equipment and technologies from abroad. So we have to stand on our own feet and to ensure that we are in the same tune of the Viksit Bharat 2047 and to strengthen the hand of our Prime Minister and to develop India. So I am going to discuss about the products which are all import substitutes, and we stand by, then I will show that we need not to anymore depend on foreign imports, at least for some products. Coming to the first product, this is a product used in space mirror applications. So you see that the product, this project has been done along with, in collaboration with ISRO. Basically, these space mirrors, if you have seen recently, lot of launches, like Moon mission, Sun mission, and a lot of launches, back-to-back launches are there, and many more are in the line, where the space mirrors are used, which is made up of low expansion glass ceramics. These low expansion glass ceramics are made of lithium aluminosilicate. In this lithium aluminosilicate glass ceramics, the beauty of it is that the property can be tailored by tailoring the coefficient of thermal expansion and improving the thermal conductivity and improving the strength, which is required at high temperature and high altitude in the space. So these have been produced, and for processing of this particular type of material requires 10 raw materials: glass former, network former, then seed former like lithium, silica, alumina-based things, zirconia, titania, then magnesia, arsenic oxide. So what I mean to say is that not only these products, lot of raw materials are involved in that. The applications, what you can see of this particular product is that this it's a mirror. Then the most domestic applications what you see at your house is nowadays cooktop. And the gas cooktop, all the glass what you see is the low expansion glass ceramics, the black color these things. So there are always scopes for improving the properties, beautifications and all those things. This finds applications. So this is a sequence of productions. I'm basically my background is scientific background. I'm a scientist, but not going much details of the nitty-gritty of the process because this is not the forum to discuss the results and all those things. But quickly, I will go through the product and just briefly the processing lines. The raw powders are taken, fed into a platinum crucible. It is casted in a mold. After casting, it is given a heat treatment. After heat treatment, controlled heat treatment gives ceramic amorphous matrix. In that, tiny ceramic nanocrystals are grown. This particularly gives very good thermal shock resistance and transparency of the materials. Coming to another application is silicon carbide space mirror substrate. This is done again with RISRO. These space mirrors are used in the space for cartographic map analysis and weather forecastings. Nowadays, you might have seen that due to this forecast of the weather and all those things, lot of lives have been saved because of tsunami on these floods and all those things comes because of these satellites gives this picture. And what satellite do? Generally in satellite there are two mirrors. One is primary mirror, is a secondary mirror. The primary mirror takes out this rays, focuses this is on the secondary mirror, then secondary mirror transmits the signals to the ground, and ground it analyzes the signals. Then it says that what is the status of the position of the wind and all those things, so that precautions can be taken. So these two primary mirrors and secondary mirrors are made up of silicon carbide, what we have already developed. The technology is available. And what I'm showing here is all the technologies available. So as sir was mentioning that no one is coming forward to set up, it's a high chance. And yesterday our Prime Minister also told this, it's a high time, it's a good time to invest, and technology can be established here. Then this is a brief about the processing. Powder is taken, then it is pressed with a big blank is pressed. The blank is then machined in a 5-axis CNC machine. You just concentrate that in each and every process how this machine is also involved. So in addition to the powder, machine is also there, so there is a lot of scopes for manufacturing of the machines. The CNC machine, 5-axis CNC machine, it gives a pocketing, because pocketing is required for lightweighting. Since it go to high altitude, this lightweighting of almost 72% lightweighting is done. Then this silicon carbide product is sintered to a density of 98.5% theoretical density, which is not enough for space mirror reflections applications. This is then further given a surface coating called chemical vapor deposition. Again, this equipment is involved. The chemical vapor deposition gives you 100% coating on the silicon carbide substrate, and subsequently it is polished to angstrom level, if nano level or angstrom level, to get a very good surface figure and surface polish. Then this is used in the space. These are the equipment what is used for processing is hydraulic press, cold isostatic press, high temperature furnace, then chemical vapor depositions, 5-axis CNC machine, ultrasonic machining. This, the offshoot of this particular project, we are proud to say, this offshoot of the project we have developed one space mirror, which is still hovering in the sky, which is fitted into Aditya mirror. You might have aware of the Aditya satellites, which is used for measuring the sun flares. Very recently, Aditya satellite has been launched. Our mirror is in the Aditya mission. It is hovering and sending the data to the ground stations. I'm not going details, it's all the same silicon carbide. Of course, it is fitted along with a silicon carbide, cold finger. Generally, this is, since it is an Aditya missions and it says the sun flares, very high temperature, silicon carbide being capable of withstanding very high temperature. The silicon carbide mirror in tandem is used with a cold finger, which dissipates the heat from the satellites in order to save the life of the electronics. Then this is basically the construction of the Aditya mirror. Then coming to another application of silicon carbide is armor. So silicon carbide armor, you know, this when the threat level is very low, this alumina and zirconia or ZT or zirconia of an alumina can be used. But for higher threat level like 3A or 3A or 4 level threat, silicon carbide is the best option for the infantry, and boron carbide is the best option for helicopters because of lightweight. Silicon carbide is density something like 3.21 and boron carbide is 2.3. We have processed this armor for both light infantry, which is going to military, And we have also developed this boron carbide armors, which goes for high altitude helicopters. So this, again, these are the jackets which is made out of these armors. These have been tested in Forensic Science, Gujarat, Gandhinagar Forensic Science University. It has given a very good backface signature, and you can see that left side, if you see there is no, in the backface there is no signature, meaning thereby this, it has performed good. Another application of silicon carbide is thruster. For any satellite launching, any launch, the rocket launching, the thrust of the launch is required. Unless it is there, we cannot get this high speed. For any hypersonic, supersonic vehicles, nowadays we are talking about ramjet, scamjet engines, which goes very high speed, which requires very high thrust. So these are the thrusters, which is made up of silicon carbide and carbon-carbon composites. Sir Monacha sir will appreciate because he is working on that composite materials. So these silicon carbide templates are made. On that carbon fiber is woven, then siliconizing is done. Then ultimately carbon fiber silicon carbide composite thrusters have been made. This is used by ASL. As you are going to ASL next week, you will see this. Another applications of silicon carbide is silicon carbide foam has got various applications. One is the common application, industry application is that molten metal filtrations and solar thermal applications. Another application we have tried is the burner. This flameless burner combustion, if you can have a flameless combustion, then it gives very good heat efficiency, where calorific value can be achieved. So silicon carbide forms by polymeric impregnations method of polymeric sponge and silicon carbide. This type of foam structure is generated, and this technology has been proven, and this is already used by a entrepreneur who is successfully using. And this we are also trying to make various complex shaped silicon carbide products. Like you see that we are adopting now 3D printing. One of the techniques nowadays there are a lot of 3D printing techniques available. We have adopted an FDM technique, which is called fused deposition modeling technique. With this fused deposition modeling technique, we can produce components of various sizes and shapes. Last time, what I have shown in the previous slides is the thruster. This thruster, what I have shown is produced by cold isostatic pressing followed by sintering, firing. But these thrusters can be directly printed by 3D printing, or even any critical shape, bend shape tubes and all those things. The silicon carbide is used for this high temperature reactors for carbon monoxide and hydrogen, carbon dioxide, carbon monoxide, hydrogen treatment. These type of tubes can be made by 3D printing. So coming to another applications, this okay, yes.
Respected P. Swarup sir is here. Everybody put your hands together and let's welcome him in this conclave. Yes.
So, as I told, one more application is that you find that in the missiles, all the missiles of different Mach number, it's hypersonic and supersonic missiles, that the radars should be protected by ceramic materials due to these rain erosions and thermal shocks. There's various materials are available for different type of missiles, with having various Mach numbers, like Mach number ranging from 3 to 9, what we call supersonic and hypersonic vehicles. There are materials like fused quartz and silicon nitride. So these radomes of something like 600 mm, which is ojai shaped, the shape is called ojai shape, it's a conical shape of things, having 625 tall and something like 220 diameter. This is produced by cold isostatic pressing, then followed by controlled sintering and nitrogen atmosphere. Silicon nitride radomes can be used for hypersonic vehicles, and these type of radomes are very much used in defense sector. As you know, this defense is now opening up for this private government-private entrepreneurships, and lot of missiles are now in line. And since a lot of productions, a lot of quantity will increase day by day, so there are a lot of scopes. The industry can come up for processing of this type of radomes. Once the facility is established, these radomes of different Mach number, like hypersonic, for supersonic to hypersonic vehicles from Mach number 3 to Mach number 6, 7, 8, like our Agni missile, which flows at Mach number like 6, 7, these can be produced. So coming to this energy sector, so energy, we are into this solid oxide fuel cells, as I was mentioning. The solid oxide fuel cells is basically an electrochemical device which produces electricity by combining this hydrogen and oxygen. So if you can see these applications of fuel cells. Fuel cell can be nowadays very much used in forklift, laptops, then noise-free vehicles, then mobiles, then two-wheelers, as well as portable chargers. So there are various types of fuel cells available, like alkaline fuel cell, proton exchange fuel cell, phosphoric fuel cell, molten carbonate fuel cell, and solid oxide fuel cells. And solid oxide fuel cells, the performance is good because it operates at a high temperature, something like 900 to 1000 degrees centigrade, and lot of electricity can be generated out of these solid oxide fuel cells. Of course, depending upon the power requirement, we can always select the types of fuel cells. Then if we choose to select fuel cells for applications like laptop to even space, then solid oxide fuel cell is the best choice. Then the solid oxide fuel cell, various component materials are there. There is a cathode, there is anode, there is an electrolyte, and interconnect. So you can appreciate that in a particular device, there are 5 to 6 components are involved. The cathode is lanthanum carbonate, tantalum manganate, and anode is nickel oxide zirconia. Electrolyte is yttrium stabilized zirconia, and this interconnect material is again CFI, copper and iron and yttrium stabilized CFI. So 4 or 5 types of materials are included in solid oxide fuel cells, and solid oxide fuel cell has got a beauty. If we reverse this, basically reverse the connections, then the water produced in solid oxide fuel cells can be decomposed, and then this oxygen produces, this water produces very high quality hydrogen. For hydrogen, and hydrogen is the next generation fuel. So one can appreciate that the applications of solid oxide fuel cells and solid oxide electrolytic cell, SOFC and SOEC. Then here I am not going to details, but there are different types of solid oxide. This is called tubular solid oxide fuel cell, planar solid oxide fuel cells, and honeycomb shaped solid oxide fuel cells are available. And then these are the components as I was mentioning, and the equipment required for processing of each and every component of solid oxide fuel cell. You can say a tape caster is required because the solid oxide fuel cells, the components are of the order of 1.5 micron, and sometimes is 20 micron also. So it is done by tape caster followed by screen printing. So left side you can see the tape caster. Then the green, white one is the yttrium stabilized zirconia, which is what is electrolyte. The green one is nickel oxide zirconia, which is used as anode. Then there some powder is required, which is produced by equipment called spray pyrolyzer. Then this cathode powder, which is lithium manganate, which is used as cathode powder. Then the screen printer is also required for processing of all the components of solid oxide fuel cell. Here is some applications, transparent ceramics. As you know, these transparent ceramic domes and radomes are used in each and every missiles nowadays in the tactical warfare. The radomes, these radars, these sensors need to be protected. Radomes are nothing but the protections of the radomes, which having IR transparency as well as IR means infrared transparency as well as visible transparency. So there are materials we have developed a material called zinc sulfide. Zinc sulfide has a very good property of infrared transparency and visible transparency. That has gone into various missiles like NAG missiles and Emerson missiles, which is also already in use in the army. So the zinc sulfide is one of the technology where it is done by chemical vapor depositions. Zinc and hydrogen sulfide is reacted inside the chemical CVD reactor, and it is deposited on the mineral, which is pre-made mineral, and then the domes are scooped out, and subsequently it goes for polishings, and it has undergone all the tests for defense applications, and it is in use and it is in production now. Coming to another application is called spinel domes and spinel visors and spinel windows. Spinel is such a material which is used for high Mach numbers and very high, good transparency with high strength. Army is using for in the boat, in front of the boat for protection from the armor threat. It is also in nuclear powers as a window. It is used as a domes for missile applications. These particular spinel domes and missiles are used for high Mach number missiles like what do you call this, Agni, or now new missiles are there, Emerson missiles. Defense has got a lot of new missiles coming. These are particularly used for that. And you can see that in front of this army, when they are in battlefield, in front of that helmet, that visors is required. These also are used for this type of applications. This has been developed, and you can see this the spinel domes. The process is almost same to that of the zinc sulfide, which is also done by. There are two. In fact, there are two routes of processing. One is slip casting. We can produce this type of shapes. The other can be produced by cold isostatic pressing, followed by heaping, hot isostatic. Hot isostatic pressing is an essential step for processing the domes. So another applications we have developed is ceramic honeycomb for anti-mite boot applications. Generally, ceramic honeycombs, mostly people are aware that it is used for molten metal filters, but we have gone one step ahead. We have used these ceramic honeycombs for army. This is when it is made in the form of boot, hillside and sole side. It is incorporated by Army Defense Material Science Laboratory, Kanpur, DMSRD. Then a boot is made out of this honeycomb. Basically, it is a sacrificial inserts, that honeycombs. And when these boots are tested as compared to the Israeli boot and US boot, Indian boots performed as good as the Israeli boots. These have been incorporated in the army, and honeycomb finds an applications for anti-mine boot application in addition to common applications like molten metal filters. The processing is simple. This basically it's an extrusion process. The dye, specially made dye is made, and powder is made in the form of chapati dough. The dough is fed to the dye, and the honeycomb shape is taken by the dye. Subsequently, the green honeycombs are dried and followed by controlled sintering and gives these honeycomb shapes. So it has got a lot of applications. So this is a specialized applications. If the technology absorbs this technology, this can go for various applications like solar thermal applications like molten metal filtration as well as this type of specialized applications. Another application of honeycomb is societal applications, because disposing that sanitary napkins for the women, we have come forward for the some betterment of this women folk of our society. It is a burning problem in this our Honorable Prime Minister Swachh Bharat program. That burning of the sanitary napkins is a burning problem. So the incineration is the best process where this gives a ash, pollution-free ash of this waste. So honeycomb is heating elements is woven through the honeycomb. A dryer is made, and it burns the waste within no times, and leaving behind the ash, and with pollution-free burning takes place. This type of units we have supplied to schools, colleges, educational institutes, and the hostels and various places where women resides. And it has been appreciated by the ministry, and now it's basically it's a societal applications, and a lot of entrepreneur has taken the technology, a lot of business is making. Coming to another application is glass making. So not going in details. This is basically a lot of glass sealing is required, and particularly solid oxide fuel cell also gas sealing liquid and metal sealing is required. There we have made specialized glass compositions where this can be used, a special glass is made. So that's all about my presentation. Thank you, one and all. Thank you.
Thank you, Dr. Saha. Now, I would like to invite a very young and a dynamic personality, Head Technology Commercialization, Mr. R. Vignesh. Advanced Material for Healthcare and Bioengineering Applications पर वो बात करेंगे. And we are really glad to have a valuable presence of Honorable Collector Morbi, Shri Kiran Jhaveri ji, and Industries Commissioner, Shri Swaroop sir.
Good afternoon, everyone. I'm Dr. Vignesh Radhakrishnan. Okay, sure. So first of all, on behalf of Ceramet Private Limited, I would like to thank the government of Gujarat and the organizers for giving us an opportunity. And unlike the predecessors who spoke extensively about technical ceramics and traditional ceramics, of course, they pointed out all the details. I would like to divulge from the topic. And here I'll be speaking more about the application of ceramics for biomedical sectors. So basically, I'm a bioceramics expert, and we are in the business of developing hydroxyapatite, which is a calcium phosphate-based bioceramics. And is it clear now? Okay. Yeah. Okay. So I'll quickly go through what my company does, and then I'll like to brief about what are the future applications that we are looking at, and then finally, what is the future goal that we are looking at in the Vibrant Gujarat. So as I said, we are a calcium phosphate-based bioceramics company. So if you look at the Indian imports, you can see that 100% of bioceramics we are getting it from the Western countries, specifically from Europe and from US. So that puts a lot of pressure on us because the cost of the product is very high and it's not affordable by everyone. So for instance, the basic material, which is called hydroxyapatite, it is used for coating the implants. So all the hip implants and the knee implants that we put, it is coated with a powder which makes it essential so that the body can adapt to it. That is called the hydroxyapatite. So the import cost is close to 50,000 rupees a kilo. But here, if you see, we've been in this business for last 4 years, and now we are producing hydroxyapatite, which is sold in the market for roughly around 25,000 rupees. So we have cut down the price by half, and most of our customers who are into this business are located in the Gujarat belt. So we have a lot of people in Rajkot region, we have in Vasai, Valsad region, we have people in Vapi region who are purchasing it from us. And that makes it's a very essential commodity because not everyone can produce this. It's a very highly technologically intensive product, and a lot of investment needs to be made, a lot of technological advancement needs to be made, and that's why we are the first of our kind in India who are making hydroxyapatite and other calcium phosphate-based material. So we initially started off with a part of Tata Steels, and now we have gone as a separate entity, and now we are under the Lionstead Advanced Materials. So Lionstead is a venture capitalist. They are based out of Calcutta, and now we are a part of Lionstead who are into this business of calcium phosphates. So I'll not go into this Tata Steels and all, but yes, Ceramet. I'll talk about Ceramet. So Ceramet, like I said, we focus on medical materials, and our main part is hydroxyapatite. And then, of course, our future product involves our other kind of biomaterials, which involve gelatin and collagen, and also bone cements and zirconia. So the point I would like to make here is that unlike the technical ceramics, which a lot of experts are in India, the bioceramics is such a niche field that you need a lot of inputs, a lot of support from the government, because to set up such a facility, like the facility we have in Vasai, which is in Maharashtra, we are producing close to 2 tons of material a month. So to set up that, we need a lot of capex investments, a lot of subsidies and everything. And that made us self-reliant right now so that we can supply this material all over India. So, yes. So for example, the other materials of importance is your bone cements. So once we coat the implants with the hydroxyapatite powder or the bioceramics, we have to place it inside the bone. And we cannot directly put it into the bone because we need some kind of fixtures. So that fixture again is a bone cement. Now bone cement is entirely imported in India. There is not even a single company which manufactures bone cements in our country. So again, this is a very important substitute, import substitute, which we are focusing at. Then there is something called as bone grafts. Bone grafts are nothing but some parts of, when you do some surgeries, orthopedic surgeries, you cannot simply put the implant. There are some loose spaces left over, which needs to be filled with, again, some kind of calcium phosphate-based materials. So those materials, again, they are sold at, like, let's say 10,000 rupees per 10 gram. So you can see how much costly it is. It's not affordable by any common person, right? So we are again marketing it and we are selling it a very affordable price. Now basically we are B2B market. We are not selling it directly to the customers, but our customers are the secondary business people. So they do some kind of secondary operations on it and then eventually the market. So here you can see that the first orthopedic powders, or you can say hydroxyapatite, is one of the big lucrative market, not just in terms of your financials, but also in terms of serving to the country. Because we need someone who can have the final say in our country in products like this, which is a subsidiary of advanced ceramics. Bioceramics is one such kind. So we started off in 2021, this Ramet, and now here we are in 2026, and we are having a very good turnover, and we are happy to say that we are exporting the products also. So we have players, or we have buyers in Middle East, European countries, even in Asia Pacific, we are exporting our products. So bioceramics is one such field. The second field that we are focusing on is the FMCG markets. So you can see all these toothpaste, the creams, the dental applications, they all need some kind of biomaterials. Now hydroxyapatite is one such material which goes into your toothpaste. Now if you have heard about the very prominent brand called Sensodyne, right? So those people use hydroxyapatite, though we are not a supplier to them, but we are an alternative to them. And no one in India, I can claim that very well, that no one in India is making the product like we do, in the scale that we do, in the quality that we do, and in the final performances that it is exhibiting. Then the other thing is that the creams, or you can see your sunscreens, or your moisturizing creams, or your dental creams, all those things need remineralizations. So what happens is that whenever a product goes into your tooth, it tries to remineralize the tooth. It tries to enhance its sensitivity or protect its sensitivity. So on such fronts, we need a material which is potent, and that material is your hydroxyapatite. It's a naturally occurring material. It's a substitute to your bone. So if you see your bone or your tooth, it has some part of hydroxyapatite. So that is natural. But what we manufacture is a synthetic material. In a lot of the Middle Eastern countries, they ask for a lot of certifications. So specifically something like halal certificates or kosher certificates, because it's their norms. And we qualify all of those for the single reason that it is a synthetic materials. We are not using any kind of animal source or any other thing. One prominent point I would like to point out here is that in case of, let's say, your traditional ceramics, the clay materials and all, it goes for, let's say, 100 rupees a kilo or something. So we are using hydrated lime, which we purchase at a very cheap price, and we are value adding it. We are enhancing the cost of that, and eventually we are selling it at 25,000 rupees a kilo. So that's a huge addition to the market. And this has given us ample opportunities, because not just using, let's say, hydrated lime, but also using other kind of materials, and then enhancing its market value and selling it at a much higher price. So this is the need of the hour, because someday some people might stop sending us hydroxyapatite. Then how are we going to coat our implants? We cannot, because medical business is a huge industry. Close to 4 to 5 lakh implants are put into the patients every year in India, and not everyone can afford it, right? So that gives us an opportunity to put it as an alternative where we can substitute the imports, and I'm happy to say that we have covered almost 60% of the substitutes. So whatever imports was coming was 100%, now 60% of the market is being done by Ceramet. And that is a very good thing in the last 4 years. A couple of points I would like to highlight is, one was, like sir mentioned, we need ceramics which can tackle pollution, right? Now, hydroxyapatite is one such material which is very good absorbent. So we have supplied it to BARC in Mumbai, and they are using it in the nuclear reactors. So hydroxyapatite is a very good high-end alternative for nuclear applications. One is again for water purifications. Hydroxyapatite-based columns are used for water purifications. The reasons being that this is such a material, technologically advanced material, that it can act as an absorbent. It's a very funny thing that this material was discovered in China, or not discovered, made in China, Japan in 1970s. And they first made it for astronauts because their toothpaste was not mineralizing them when they were in space. And those were chewable toothpaste. So it's a very old material, 1970s, and today we are in 2026, and still we are not very confident in making such a material. So this shows us that we lack a little, but of course we are trying our best. Company like us, we have a very advanced team with us. We have PhDs from premier institutes in our country. We have leaders from different parts of the country, and we are pushing it. The other thing is, like sir said, geopolitics is very important. Yes. So raw materials, it's a very difficult thing to get. So such a material is using very common raw material, calcium hydroxides and phosphoric acids and all. But also Ceramet as a company is trying to venture into other parts of ceramic industries, some of them being like silicon nitride. So now the semiconductor industry is changing gears, and people want to make them in India. So silicon nitride is one such lucrative option which we can use, or we can make in India, so that it can act as wafers for your semiconductor industries. And SOFCs, like sir mentioned, solid oxide fuel cells. So they use something called as yttria stabilized zirconia. Why is it? Now, yttria stabilized zirconia not only goes into solid oxide fuel cells, but they are also a part of your medical industries. So all your joints, hip joints, knee joints, they are made up of such materials. So this gives us, again, another field where we can explore. And now, in Vasai, we are employing close to 70 to 80 people, but we are in the path of expansion. And since our major customer base is based out of Gujarat, so it's a very, very sensible idea for us also to explore Gujarat as a base, and with such a great initiative by the government of Gujarat, where they want to attract people to venture into the ceramics. And I would say that bioceramics is one such field where no one has entered in India, and it's something which we have to look forward to. So if you look at product portfolio, okay, so here you can see, so these are the hydroxyapatite that we make, and we have customers all over India, we have in abroad, and then you can see our material has gone into patients, we have implanted it, we have tested it, we have published results based on it, and it has been globally accepted. So our hydroxyapatite production plant, we published a paper which was accredited by, you can see, John A. Markey Award we got in 2023 for this. No one in India has done that. So we initiated this process, we are carrying out this process, and today we stand as the sole supplier of hydroxyapatite of high quality in India. There are substitutes for this from China. So we know people who get it from China, and when we compare our product with their products, we are far ahead of them. So even though we are selling it at, because China, they all give it to at a very cheap price, right? But since quality matters most, and that too when it comes for the medical materials, you cannot compromise on the quality. Yeah. So I would like to call all of you to please visit us in Vasai whenever you get the time, because you cannot see the gravity of this until you see the manufacturing efforts that goes into it. There is a lot of efforts. You have to control, if we speak technically, we need to control the pH to such a small margin that if it goes here and there, the entire batches goes away. and the cost of manufacturing shoots up. So such critical conditions are there, such critical parameters are there, which we need to modify and then come up with it. One more product I would like to focus right now is high purity graphite. Now this is not a part of ceramics, but yes, we need to focus on graphite also, because graphite has endless applications, not just in medical industries, not in ceramics, but semiconductors and then your defense applications. And the thing is, we do not have any player in India who supplies a 99.9% pure graphite. And that needs a lot of investment, that needs a lot of technical expertise, and that needs support from the government. Unless we have some kind of collaborations with people, it's very difficult to venture into such a market. So, yes. And then, yeah, I won't go much into the PPTs because I was told that there will be no PPT, so I didn't make one. But yes. So apart from that, one other thing is like we want collaborators, because what happens is we want to expand our plants and we need to have our base close to our customers, and it's only wise that we have such an operation base in Gujarat. And with such an initiative from the government of Gujarat and their initiative to push it forward and take it to the other level, it's only imperative that we have a base in Gujarat. And we want to collaborate with people who can support us in this, who can be a partner to us in this progress, because this is just the beginning. If you look at the market for bioceramics, close to 60 crores of biomaterials are imported in India. We have done the market study ourselves. So people from Switzerland, the companies from South Korea, then everyone is supplying to India. And the reason being that we do not have any alternatives. Now people are coming up with medical device parks in Telangana, I have seen, in Tamil Nadu, I have seen, all those places I have seen. They are getting into this business. They are making implants, they are making small steps. That is still, it's still a good, but ceramics as such, bioceramics is still a far-fetched dream for all of us. So saying that, I would request all of you to please come over, visit our facility, look at the work we are doing, and then push your team also to work in the field of bioceramics, because if there is no life, there is nothing to do, right? So we have to work toward the betterment of our people, we have to work for the enhancement of our lives, and being such a big population, our own country is the biggest market for us. We need not go outside. Of course, exports are always there, but unless we cater to our own people, there is no point in producing anything. So we should do that, and we should work together, and maybe by 2047, we should be self-reliant in each and every field of ceramics, not just bioceramics or technical ceramics, but everywhere. So having said that, I thank you very much for this opportunity, and thank you. Yeah.
Thank you, Mr. Vignesh, for a very prominent presentation and your speech. તો વાઇબ્રન્ટ ગુજરાત રિજનલ કોન્ફરન્સીસ જેનો આજ ઉદ્દેશ્ય છે લોકલ ટુ ગ્લોબલ મેક ઇન ઇન્ડિયા, મેડ ઇન ઇન્ડિયા અને આત્મનિર્ભર ભારતથી એક વિકસિત ભારત સુધી પહોંચવાની આ સફર, અને એના માટે જ ગુજરાતના અનેક અને અનૂઠા પ્રદેશ સુધી આપણે જઈ રહ્યા છીએ. અને એમાં જ આ વાત થઈ રહી છે સિરામિક્સની. વિધિન 15-20 મિનિટ્સ ઓનરેબલ યુનિયન મિનિસ્ટર શ્રી પિયુષ ગોયલજી આપણી વચ્ચે હશે. અને હવે I would like to invite our another prominent speaker, Mr. Amit Saluja, Managing Partner, Digital XLT Consulting LLP. He will discuss with us Industry 5.0, smart manufacturing and its application in the ceramic industry. Welcome, sir.
Okay, good afternoon, everyone. It's a great opportunity to be at Vibrant Gujarat. Thanks to Gujarat government for giving me this opportunity. And this is a topic which is very close to my heart. So just to briefly talk about why this is critical and important. So I've worked for about 25 years in corporate. So it was a global companies for 25 years I worked. Then after that, I was thankful for again, a huge opportunity that I got from the government of India and Gujarat government, that was to run a center in Gandhinagar, which was for accelerating digitization in the manufacturing sector of the country, and with a more focus on the MSME sector. So I led that for 5 years, and it was a great experience because I got to meet so many MSMEs across country. Around 3,000 MSMEs basically I've kind of engaged. There are more than 300 manufacturing plants I have visited. I have seen on-ground challenges that every industry is facing, and there's a lot of visits that I did in the Morbi sector also. So that's where I saw the problems that a ceramic industry is facing. And everything whatever I will talk about, it will be more about how we can address the challenges that the industry is facing and using the technology. I think technology has become a center for every change that we want to bring up in a country, and right from our PM and every government basically is talking about the use of a technology. The challenge is, especially in the MSME sector and the mid-sized manufacturing companies, there are a lot of issues that are come up in front of, like when you are really thinking of adopting the technology, and that's where I thought I'll clarify some of those challenges. And at a basic level, what really can be done to have a smooth digital adoption process, correct? So I will define some kind of an roadmap for the organization to basically digitalize their manufacturing plant. And other thing is, whatever I will focus, it will be more from a manufacturing point of view. While in the organization there are many ways technologies can be adopted, but considering we are really little bit of a behind on the manufacturing side, so that's where I will focus more on the manufacturing. So with that, let me start with in the manufacturing sector, what kind of challenges we have in specific on the ceramic, correct? So these are some issues. Basically, what I have experienced again is based on the plants that I have visited in Morbi and some of the other clusters. So I think number one I will say is the global competitiveness. We are basically producing still at a low cost, but still global competitiveness will always be a factor, because there are a lot of other global countries who are coming up in the ceramic production at a much lower cost, and plus ability to produce at a lower cost, and again of a high quality product at a lower cost. So that's where becomes the challenge. And the cost that China is producing definitely is below us. And why they are able to produce is only because they use to some level of a technology that they are using, and which is why I think we should also look at how technology can help in producing at a lower cost. Second is the overall capacity utilization in the plant, and I think this is also, I have seen the capacity utilization in ceramic industry is also very unpredictable. One is from a demands point of view. The orders basically doesn't flow in as it should be. That is the one reason. But otherwise, within the plants also, there are a lot of issues. Sometimes material issues, sometimes there are manpower issues, sometimes machine breakdowns. So something or other which keeps happening that limits the capacity utilization. When we say that what should be an ideal capacity utilization of a plant, it should be at least 80-85%. Then you can say that we are a world-class factory. And I think a lot of us might feel that we are at 80-85%, but actually when you will have a real data to back it up, you will realize that the capacity utilization will turn out to be not more than 50-55%, which means within the current level of a resources only what you have, there is an opportunity to produce more, there is an opportunity to produce at a much lesser cost. Then there is a lack of operational visibility, right? So again, companies have ERP there, but ERP doesn't provide the level of a shop floor level visibility that is really needed. For example, if I want to know at each of an operation level, what is my manufacturing cost? Clean के ऊपर manufacturing cost क्या है? When we are doing digital printing, what is my manufacturing cost of a product? If I am doing pressing, then what is the level of a manufacturing cost? Correct. So at each of the operation, when a whole value chain, when a material comes in a plant and that say ceramic product goes out of it, tile goes out of it. At every operation, what is the cost basically that I have? That is very difficult to assess. And even we can also say about the wastages that are happening, the yield which we are able to achieve, correct? So there is a very less clarity about what is the right level of a products, or what is the right level of a cost that we have. Then there are always a margin pressure within the plant on how do we produce at a lesser resource consumption, basically energy consumption, like in the plane also there is a lot of energy consumption which is there, fuel consumption which is there. Then from a material point of view, it becomes an expensive part of it. And then from a long-term sustainability point of view, that at what level we will keep getting the same material, correct, that's also a challenge. And then the manpower cost. Still the ceramic industry employs huge amount of a manpower within the plant, correct? So the cost from a manpower also basically is more. Then there is what I have seen is there is a high level of a rejection, breakage and rework, and that rejection can be maybe because of some alignment issues, it can be some color discoloration, or there are multiple defects basically that comes up. So that also adds to the cost. And most of the times the rejection only you get to know basically after the complete process has happened. So basically after the clean process has happened, then only you will get to know the rejection. So the material would have passed through several operation steps, and then you'll get to know the rejection at a later. So what can we do to basically reduce the rejection part of it, so that again the cost also basically will come down. And I think this last point is again important, because from a mindset point of view, one is mindset and other is because of the day-to-day challenges that you all are facing. Because when we go to a factory, we always think of आज का production करना कैसे है, कोई issue नहीं आए उसको कैसे handle करना है, correct? We don't even really think of, if we are a 100 crore company, what do we do so that we become 200 crore company in the next 3 years? We are not able to do it only because we don't get time to really think about it. The whole time in the business goes into the day-to-day operations. We are not able to come out of the day-to-day operations, and that limits our thought process to think bigger, right? So now what can we do to get time out of our factories and make ourselves available for growing the organization, correct? So these are the things that I will talk, and this is a simple slide. So I do a lot of awareness session, and every session basically I start with this slide. So if you see, there are 3 set of people, basically personas here you have. On the left, you will see a person who is happy. On the middle, you will have a person who's very excited, the person is bumped up, correct? कुछ करना है, कुछ बड़ा करना है, कुछ और कुछ करना है, correct? And the third person, basically, you will see is a frustration. Frustration is from the day-to-day issues, day-to-day management. घर पे time नहीं मिल रहा है, family के साथ time नहीं मिल रहा है, plant में इतना सब चल रहा है, correct? So what I will say, technology उसके लिए है जो नंबर 2 और नंबर 3 पर है. अगर आप नंबर 1 पर हो तो टेक्नोलॉजी आपको बेनिफिट नहीं देने वाला, बिकॉज यू आर हैप्पी विद व्हाट यू आर हैविंग इन द प्लांट, यू आर हैप्पी विद योर ग्रोथ प्लान्स, यू आर हैप्पी विद योर डे टू डे इश्यूज, करेक्ट? सो देयर इज नो चैलेंज in that. But I think that situation, if I do a survey also, and if I ask you that whether you want to grow or whether you have a big challenges or not, I think out of 10, 9 will say yes, I basically belong to the level 2nd or 3, correct? So which is what I'm saying, technology will help you, provided you come out of your mindset and be in a category of second and third. Till the time you are in a stage of first, technology is not going to help you, and you will not be able to even think of doing the ROI calculations. ROI calculations अगर stage 1 में होके अगर हम करेंगे तो ROI calculations कभी ठीक नहीं होगी. Next is growth. In India, we are talking about Viksit Bharat. Viksit Bharat 2047, there is a huge amount of a growth in a manufacturing has to happen. We have to become a manufacturing capital of the country, of the world. That will not just happen by making more factories. अगर अभी 2000 factories है मोरबी में, उसको 4000 भी कर दो, correct? That will not just. और जो infrastructure चाहिए और जो efforts चाहिए 2000 से 4000 करने में, it is huge. Why can't we produce more from our same resources? Why can't we improve our capacity utilization? Why can't we expand our capacity within our same plant, within our same resources? And I'll tell you basically how to do it using the technology. So I'm running a little fast because I think I'm just aware of the time also, but okay, great. So this is basically again an important topic. Again, as I said, I mean, I've engaged with almost 3,000 MSMEs, and this slide is more from an MSME point of view. I go to the plant and then I talk to them on technology adoption, and everyone says automation karna hai, correct? So there is a huge mindset difference or a myth basically where it says that we don't understand that broad or real level of, I'm saying I'm saying only a manufacturing segment. I mean, so while technology persons will understand definitely this business, this thing, automation or digitalization में क्या difference होता है? Okay, so automation is basically if in a manufacturing plant we replace the physical effort of a labor with the machine, correct? So that is simply the automation. कोई भी पार्ट को, प्रोडक्ट को प्रोड्यूस, ऑपरेशन करने का टाइम, प्रोड्यूस करने का काम या फिर मटेरियल ट्रांसफ़र करने का काम, स्टेज 1 से स्टेज 2 में ऑपरेशन को मटेरियल ले जाने का काम, या जो पर्सन हु इज प्रोड्यूसिंग, करेक्ट? इफ वी मेक दैट पार्ट, दैट एफर्ट डन थ्रू द some machines or something, that becomes the automation. Digitization or digitalization is basically the use of technology to replace the intellectual work also that the person is doing, non-physical work, correct? So जब हम plant में होते हैं, जो workers आज की date में जो लोग काम कर रहे हैं, वो non-physical work में काम कर रहे हैं. Physical work तो हम मशीनों से कर ही रहे हैं, correct? हमारे level पर जो automation हमारे industry में और हर industry में plants में automation is at a very good level. हम वो स्टेज पर नहीं है कि वर्कर जाके कुछ प्रोडक्शन कर रहा है. वर्कर जाके ओनली इज ऑपरेटिंग द मशीन्स. सो विच मीन्स वर्कर इज नॉट डूइंग द एक्चुअल फिजिकल वर्क, वर्कर इज डूइंग द इंटेलेक्चुअल वर्क. तो अब जो स्टेज है बेसिकली डिजिटलाइजेशन में कि कैसे हम वर्कर का जो इंटेलेक्चुअल वर्क जो हो उसको हम कैसे हम टेक्नोलॉजी से कर सकें, एंड विच इज़ वॉट द डिजिटलाइजेशन डज. In automation, each of the machine equipment works isolated, correct? वो stand alone रहते हैं. एक machine दूसरी machine से बात नहीं करती. When we say we digitalize the plant or a smart manufacturing or a digital manufacturing or industry 4.0 or industry 5.0, जितने भी आपने words if you are saying, they all are the same. What it means is basically the plant is not a standalone plant. In this case, plant becomes an integrated plant where one machine can talk to the other machine, worker can talk to a machine, machine can talk to a worker, machine sitting at a shop floor can talk to person sitting in a office, correct? So there is a communication channel that opens up in a manufacturing plant. And we all know that कि जब communication होता है तो productivity बढ़ती ही है, correct? अगर हम अपने ऑफिसेस में भी अगर हम 10 लोग जाके बैठे हैं और 10 लोग काम कर रहे हैं, आपस में बात नहीं कर रहे, उनके बीच में आपस में बात करने के लिए कोई तीसरा अगर इंसान रख दें, तो ऑब्वियसली देयर इज ए लॉस ऑफ प्रोडक्टिविटी इज हैपनिंग एट ईच ऑफ द स्टेज. एंड व्हाट डिजिटलाइजेशन एस्टेब्लिशेस बेसिकली कनेक्टिविटी बिटवीन द मशीन्स, कनेक्टिविटी अक्रॉस द मैन्युफैक्चरिंग प्लांट, सो दैट जब जो हो रहा है, चाहे वो अच्छा हो रहा है चाहे वो खराब हो रहा है, it gets communicated immediately and the action gets done immediately. अगर ख़राब हुआ, अच्छा हुआ, अगर हमें उसका एक बाद में भी अगर उसको करना है कि पिछले 6 महीने में कहाँ कहाँ पर क्या ठीक था, मेरी एनर्जी कॉस्ट पूरे 6 महीने में कैसे वेरी हुई, क्लीन के कितने ब्रेकडाउन हुए, मेरा आइडल टाइम कितना था प्लांट में, आइडल टाइम अगर 2 घंटे पर शिफ्ट का और पर डे का था, दैट उस 2 घंटे का ब्रेकअप क्या था, एक महीने में आइडल टाइम बिकॉज ऑफ द मेंटेनेंस एक्टिविटीज़ कितना था, एक महीने में बिकॉज ऑफ द मटेरियल के लिए आइडल टाइम मेरा कितना आया, करेक्ट। ये सब लेवल की चीज़ें बेसिकली अगर डिजिटलाइजेशन होगी तो आपको पता लगेगा। सिर्फ ये, और यहीं से बेसिकली प्रोडक्टिविटी और एफिशिएंसी आती है, और उसी से बेसिकली आगे जाके यू कैन इम्प्रूव द ओवरऑल कैपेसिटी यूटिलाइजेशन ऑफ द प्लांट, करेक्ट। हमारा एम क्या है, एवरीवेयर वॉट एवर आई एम स्पीकिंग, एम इज टू इंक्रीज द कैपेसिटी यूटिलाइजेशन फ्रॉम द सेम सेट ऑफ रिसोर्सेज, एंड आई कैन गारंटी every manufacturing plant whose owner who's sitting here can improve the capacity utilization with the same set of resources without hiring any single person, without hiring any other, without taking any other machines, without taking any other extra material. Production cost will come down. Next is basically हम टेक्नोलॉजी में आगे जाते क्यों नहीं हैं, करेक्ट। बिकॉज हमारा एक माइंडसेट अभी बेसिकली है कि lean, continuous improvement, basically we all keep thinking of continuous improvement. Continuous improvement basically गलत नहीं है, continuous improvement होना चाहिए and it should be there regularly. But that big change or a huge change will only come from a transformation. And you can check in the history of any industry, not just manufacturing industry, of any industry, any transformation which has happened, it has always come through technology only. There is no transformation which will happen without technology. आज की डेट में हम easy to वे में गाड़ी बुक कर लेते हैं, वो क्यों कर सकते हैं, क्योंकि टेक्नोलॉजी है। आज की डेट में हमें बेटर रेट्स मिलते हैं होटल्स के, तो क्यों मिलते हैं, बिकॉज वी हैव ए टेक्नोलॉजी। ऊबर कैसे आया, अगेन बिकॉज ऑफ ए टेक्नोलॉजी। यूपीआई आया, यूपीआई आने से क्या इकोनॉमिक लेवल पर ही चेंजेस हो गए, you can see the transformation, correct, again। so transformation कैसे आई, टेक्नोलॉजी से। अगर टेक्नोलॉजी नहीं होती तो यूपीआई नहीं होता, अभी भी हम बैंक्स की लाइन में लगे रहते, उससे कितना लॉस होता, करेक्ट, दैट्स द अदर थिंग। सो ट्रांसफॉर्मेशन करनी है, ट्रांसफॉर्मेशन करने के लिए बेसिकली हमें रिस्क भी लेने पड़ेंगे, एंड what we need to be clear is there is when you want a rewards you have to take a risk, जितना रिस्क उतना रिवॉर्ड, करेक्ट। सो and I'm not saying you for a technology you take a big risk, but at least take some level of a risk। इस risk का मतलब ये है कि जब when you are taking a technology decisions, even though if you have not clarity about the ROI, at least some level of investment you commit, because initially अगर data नहीं है तो ROI calculation नहीं हो सकता, it is impossible। You will be able to do the ROI calculations only if you have a data। So have some level of a risk, take decisions, get the ROI assessment, and then take bigger decisions, correct। so that's the way to move forward। now I'll give you simple use cases basically in a ceramic industry जहाँ पर आप digital use करके again it will positively impact the capacity utilization। these are not all the use cases, if I come to your plant I will talk about many more use cases, but अगर मुझे अभी आपको सिर्फ selected आपको use cases बताने हैं कहाँ पर आप एटलीस्ट सोच सकते हो अपने प्लांट के ऊपर प्रोडक्टिविटी इंप्रूव करने के लिए, दीज आर द थिंग्स। फर्स्ट इज द बैच एंड प्रोसेस लेवल मॉनिटरिंग, विच मीन्स यू शुड बी एबल टू मॉनिटर योर कंप्लीट प्रोडक्शन प्रोसेस डिजिटली, कि देर शुड बी सम सिस्टम इन प्लेस वेयर जब डेटा जनरेट हो रहा है मैन्युफैक्चरिंग एक वर्क स्टेशन पे या एक मशीन के ऊपर, जब डेटा जनरेट हो रहा है वो डेटा शुड बी जनरेटेड डिजिटली। दैट्स द वन थिंग दैट यू शुड हैव। डेटा डिजिटल जनरेट हो, डिजिटली ट्रांसमिट हो किसी एक जगह पर, डिजिटली एनालाइज हो, और उसके बेस पे बेसिकली यू आर एबल टू एनालाइज एंड व्यू द रिजल्ट्स। Second thing is the quality inspection। so I think you all would have seen this thing in some form, the machines basically say after, I mean this can be used at a multiple places। this is basically a camera rahega, camera will take a picture of the whatever the ceramic product is there, tile का जैसे है tile का वो picture लेगा, and then the camera at the back, there will be an AI system will be there. It will analyze कि इसके अंदर कोई defect है कि नहीं. Even the dimension measurements also basically it will do. You all know that, I mean, even if the अगर if you are manufacturing a tile, अगर वो 2 mm का भी अगर उसमें difference आ गया, तो वो site पर tile वो fit नहीं होगी, correct? So which is why it becomes a rejection for you. So you need to ensure कि जो dimensions भी हैं, वो accurately मेजर हों, उसके बाद ही साइट पर या जो भी कस्टमर को डिलीवर हों. एंड डूइंग दिस डायमेंशन मेजरमेंट मैनुअली बेसिकली अगेन नॉट very accurate. The person who is doing this dimension measurements, if he does 1,000 tiles measurement in a one day, imagine how many tiles measurement he will be doing in a month, 1 month. The person is a human. Person will also get tired. Someday person will not be in the right mood, correct? So person will make error, even though doesn't want to make error. Which is why the use of technology basically helps. Camera kabhi thakega nahi. The camera will work at a same level of an efficiency, same level of a accuracy. It will really give you. So which is why this system is highly recommended. When you build this system, I think we need to be little careful because usme accuracy is very important, especially the dimension part of it, because it runs into the microns and the millimeter, correct? So that's where the person who's working with you to develop the application, I think the proper monitoring of it has to be done. Third is the recipe management. Recipe management basically again is a big upcoming area where AI can help. So if right now you will have material that will basically product that gets built using say 4 or 5 materials along with few compounds, correct? Now how can you optimize the recipe? Optimization of recipe means 1 or 2 incremental changes if can be done in that recipe, either in the composition or maybe with the material or maybe in the volume, correct? Whatever the changes, if it really can be done, and if it can help in improving either the quality or the yield, correct, then it could be a big help from a manufacturing point of view. And again, AI solutions here are there basically which helps in optimizing the inventory. Basically, AI will come and tell you कि इस रेसिपी के अंदर आप ये थोड़ा चेंज करोगे तो आपको बेटर यील्ड मिलेगी, बेटर क्वालिटी मिलेगी, करेक्ट? सो दिस मीन्स द क्वालिटी इंप्रूवमेंट विल नॉट जस्ट हैपन एट द लेटर स्टेज, करेक्ट? अगर रेसिपी में चेंज हो गया तो जितना जो आपका कॉस्ट लूज हो रहा था, क्योंकि अभी तो आप क्वालिटी के इश्यूज पता लगते हैं विच इज़ एट द लास्ट स्टेज जब हम फाइनल टाइल का इंस्पेक्शन कर रहे हैं. इन दिस केस यू विल गेट टू नो अर्लियर ओनली of basically, so you can reduce the quality related issues. Then what we have is condition monitoring. I mean, iska next level bhi aata hai. Basically, the larger manufacturing, global manufacturing companies are doing now predictive maintenance. What I am suggesting is at least have a condition monitoring. And then basically you go to the predictive maintenance. In condition monitoring is basically you will have simple sensors, either they are of the machine or they can be put on the over the machine as a additional sensor. The data basically which will come in, which regularly will get analyzed, and from that data you will get to know of the health of the machines, and you will have an idea of if this machine or equipment can fail in the future. At least clean के ऊपर तो condition monitoring is a must, because clean is such an important integral part of your plant. अगर जिस दिन clean अगर में problem हुआ तो पूरा plant बंद हो जाता है, right? So at least clean का तो regular monitoring should be there. Condition monitoring is nothing like जैसे हम human हैं, basically someone goes to a ICU, and in ICU there is a complete monitoring of it is done, correct? So that it is not incremental. हम regular maintenance करते रहते हैं. वो क्या है कि हम basically हम regular checkups कर रहे हैं, which is the health checkup that say we undergo. But for certain kind of an equipment, basically the condition monitoring is going to be very helpful. Then the utility optimization. Utility optimization is all about the optimizing the consumption of water, consumption of gas, consumption of fuel, consumption of energy basically in the plant. And again, iske liye bhi AI based solutions are there which can help you optimize the energy usage, optimize the water consumption, correct? We were seeing in the previous session कि 70% of the water अगर RO में जाता है तो वो waste हो जाता है. So how can we optimize the overall ROI, overall water consumption basically? So that's the one thing. Last is from a safety and compliance management also. Up basically in a manufacturing plant, especially with such a labor intensive industry, I mean, while there are machines, but still ceramic industry is a labor intensive. There is a huge amount of labors are there. So there the managing the safety and the compliance management incidents also are very basically critical. The iska solution, again, it is not an expensive solution. There is a simple, जो आपके अभी CCTV camera जो plant में अभी लगे हैं, using those CCTV cameras only can be used. उसके साथ basically there will be just one component of AI which will get added, and that AI component will keep on monitoring if there is any kind of an compliance issues which is happening, or any kind of a or any kind of an safety issues which has happened, correct? So the complete monitoring of it.
We heartily welcome Honorable Minister Shri Jairam Bhai Gamit and Srimati Mamta Verma ma'am, Additional Chief Secretary, Industries and all. In this vibrant Gujarat Regional Summit, Ceramic Conclave पर बात कर रहे हैं, and let's continue please.
Okay, so from the, as I was saying, from the safety point of view also, the regular cameras, CCTV cameras can be used that will monitor the safety of it. No additional hardware basically which needs to be installed in the plant. Same cost, there is not much of a high cost, correct? And the best part is whatever the solution basically I have explained here, all of these solutions can be adopted by MSMEs. I am not talking about as these solutions are a very high cost solutions. These are all of these solutions have been implemented by the global companies. So which means इसमें issues नहीं है कि like something like these solutions needs to be tried, that will these solutions work or not. These are the solutions which has been tried and tested by all the global companies. What we need to do is basically the solution which are made at a level of a global companies needs to be customized little bit, needs to be made in a way that some frills of that have been removed, and then customize it at an MSME level, so that same level of a solution can be afforded by the MSMEs also, correct? And I can tell you all of these solutions can be afforded by the MSMEs. This is not a very high cost solutions. So next is, I mean, just a one slide which says कि plant में issue होते क्यों हैं basically. So if you see that अगर कहीं पे breakdown हुआ 10 मिनट का, because of that 10 minutes of a stoppage, what will happen is quality process will get delayed by 15 minutes, packaging process will get delayed by 30 minutes, delivery process will get by another 1 year. So a 10 minutes of a break stopover can lead to a 1 hour of a actual impact to the delivery, correct? So these are the things basically which we doesn't get to know, because we really don't have a data within our plant which can tell that कि 10 मिनट का अगर कहीं पे ब्रेकेज हुआ था उससे डायरेक्ट इम्पैक्ट तो हमें पता है, लेकिन उसकी वजह से इनडायरेक्ट इम्पैक्ट और कितना हो जाता है बेसिकली दैट वी डोंट गेट टू नो, correct? So which is why these kind of a thing is helpful. It's just a one solution basically. I will simply explain here what a solution could be. So the solution is again digitally how can we do it in a medium size or small size organization. We really don't need again a heavy investment. What we do is basically these are simple tablets based system where you first of all you do your production planning in the tablet, which means production planning means कि अगर आज के दिन में अगर 10,000 टाइल्स बनने वाली हैं, 10,000 टाइल्स में कौन सा मटेरियल यूज़ होने वाला है, कौन से लाइन पर चलने वाला है, कौन कौन सी मशीन पर कब कब क्या होगा, विच आर द वर्कर्स हु विल बी वर्किंग एट ईच ऑफ द मशीन, विच मीन्स इट इज़ बेसिकली द शेड्यूलिंग ऑल्सो और द राउटिंग. शेड्यूलिंग एंड राउटिंग कभी भी ईआरपी में नहीं होता. ईआरपी में ओनली व्हाट इट हैपन्स इज कि आज कितना माल बनेगा, कितना मटेरियल कंज्यूम होगा और किस ऑर्डर का बनेगा, इससे ज़्यादा कुछ भी नहीं होता किसी भी ईआरपी के अंदर. करेक्ट. सो विच इज़ वाई अगेन ए सिंपल टैबलेट बेस्ड एप्लीकेशन है. आपने शेड्यूलिंग कर लिया, एलोकेट हो गया, उसके बाद व्हेन द टाइम इट कम्स टू द डेटा रिकॉर्डिंग, अभी वर्कर पेपर पेन पर जो रिकॉर्ड करते हैं वही चीज़ बेसिकली दे हैव टू रिकॉर्ड ऑन द टैबलेट. एक सिंपल एप्लीकेशन टैबलेट पर रहेगा विच विल बी बेसिकली एज सिंपल एज यूजिंग ए व्हाट्सएप. उसके अंदर टाइम रिलेटेड एंट्री वर्कर को कुछ नहीं करनी, बिकॉज टाइम अपने आप टैबलेट से आ जाएगा. तो टाइम रिलेटेड एंट्री सारी खत्म हो जाएंगी वर्कर्स की. only the some of the basic level of say process parameters, rejections, correct. So those are the things which worker will add there. और उसके लिए भी ड्रॉप डाउन और टूल किट बेसिकली साथ में लाए जाते हैं सो दैट वर्कर के लिए ये करना एकदम सिंपल हो जाए. एंड बेसिक लेवल ऑफ ए ट्रेनिंग से वर्कर को बेसिकली ये हम सिखा सकते हैं. अब द मोमेंट द डेटा इज डिजिटल, अब मैनुअल नहीं है, तो इसका मतलब वो डेटा सीधा बेसिकली सिस्टम में गया, ऑटोमेटिक उससे रिपोर्ट बना. तो जो इवनिंग में हम 2 घंटे लगाते हैं कि रिपोर्ट बना रहे हैं बेसिकली, वो टाइम ज़ीरो हो गया. राइट. सो दैट टाइम हैज़ बिन सेव्ड. देन यू विल हैव ए रियल टाइम डैशबोर्ड्स इन फ्रंट ऑफ यू कि अभी प्लांट में क्या चल रहा है, कौन सा मटेरियल यूज़ हो रहा है, किस एफिशिएंसी लेवल पर चल रहा है. अगर मेरा क्लिन है तो क्लिन की एफिशिएंसी लेवल क्या है, उसकी कैपेसिटी यूटिलाइजेशन क्या है, इन्वेंट्री में कौन कौन से मटेरियल शॉर्ट हो रहे हैं. एवरीथिंग बेसिकली द डैशबोर्ड फॉर्म में आपके पास आएंगे. सो एज ए ओनर बेसिकली यू रियली डोंट हैव टू गेट इन टू द डे टू डे monitoring of it. Correct. So everything will be there right in front of you in a digital format which will help you in taking a decisions. You will get to know कि पिछले 6 महीने में अगर आइडल टाइम हुआ था तो आइडल टाइम की में उसमें से मेंटेनेंस रिलेटेड कितने इश्यूज थे, मटेरियल रिलेटेड कितने इश्यूज थे, एवरीथिंग बेसिकली ऑल द इनसाइट्स यू विल गेट टू नो. और अगर आपके पास इनसाइट्स है देन यू डोंट नीड एनी कंसल्टेंट टू टेल यू व्हाट एक्शन टू टेक, बिकॉज यू आर द बेस्ट person to know your plant. If the problem is only that you don't have an insights. अगर insights मिल गया you will take decisions कि अब मुझे improvement में क्या करना है, क्या बड़े level पर changes करना है, so that I am able to make the things better. Correct. So what it save is planning effort. Planning के बाद scheduling effort. सारा manual काम basically it becomes minimized. Data recording time basically shop floor से paper खत्म हो जाएगा. All data recording time basically will get minimized. Data reporting time will become 0. And plus then you will have an insights कि अब insights के base पे हमें improvement plant के अंदर कैसे लानी है. Correct. So that's where the simple basic solution. No complicated hardware. सिर्फ एक tablet होगा जिसको tablet person use कर रहा होगा. कोई hardware additional नहीं आएगा. बनाने का effort भी basically it doesn't take a lot of effort to really make it. Within 1 month these kind of solutions can be deployed in the plant within 1 to 1.5 months. Correct. It's so simple. And no changes in the process level. जो आपका अभी process है वही process चल रहा होगा. Workers के लिए भी कोई change नहीं होगा. जो entries workers अभी कर रहे हैं उससे कम एंट्री ही करेंगे और उसी तरह की एंट्रीज करेंगे. करेक्ट. वर्कर्स के लिए भी कोई चेंज नहीं होगा. सो विद द मिनिमल लेवल ऑफ ए डिसरप्शन इन द प्लांट बेसिकली यू कैन गेट टू नो. सो द पॉइंट इज बेसिकली कि मेजर आई मीन अभी अगर मैं सेरेमिक से कंपेयर करूँ. करेक्ट. सो देयर आर अदर इंडस्ट्रीज लाइक इलेक्ट्रॉनिक इंडस्ट्री, ऑटोमोटिव इंडस्ट्री. सो दीज आर द इंडस्ट्रीज who have adopted digitalization to a much bigger extent than the ceramic. Correct. So why ceramic industry basically cannot do and why it is not happening. Correct. So why mid-size manufacturers are not able to adopt. So these are the reasons why digital adoption becomes difficult for the mid-size manufacturers. First is the digital skills gap. Like in bigger companies, there are always 1 or 2 people who understands technology, who understands the solution, so that way they help in guiding the organization in moving on the digital path. But in a smaller organization, we don't have a luxury of having a specific technology people, say even though 2 or 3 in the plant, correct? So वो एक skill gap basically रह जाता है. And skill नहीं है तो then we are not able to assess right level of an ROI also. क्योंकि skill नहीं है तो ROI assessment और data नहीं है तो ROI assessment also becomes difficult. Second part is कि हम कंटिन्यूस इंप्रूवमेंट में ही इतना अपने आप को ऑक्यूपाई कर लेते हैं, वी आर नॉट एबल टू रियली थिंक ऑफ द ट्रांसफॉर्मेशन लेवल. वी कीप थिंकिंग अबाउट क्या क्या छोटे छोटे चेंजेस करने हैं, वी डोंट थिंक ऑफ कि बड़े लेवल पर हमें क्या चेंज करना है जिससे कि हमें लॉन्ग टर्म में और बड़े लेवल पर फायदा हो, करेक्ट? सो वी आर नॉट एबल टू थिंक देयर. Then we have not seen the solutions in small companies. We don't even have success stories. अगर companies में basically in MSME sector, if we don't have people who come forward and adopt the technology, then from where the success stories will come in. And as a manufacturers, like when I go and meet manufacturers, people always say कि हमारे पास आप success stories लेके आओ, correct? So success stories बनाने के लिए भी first we need people who are willing to come forward and willing to take something. Then only the success stories will get generated. And last thing is manufacturers also I have realized people feel that कि workers resist करेंगे, correct? So they will not support it. वो नहीं कर पाएंगे. I think that's a more from a myth from our side. अगर worker WhatsApp use कर सकता है तो worker ये भी use कर सकता है. वर्कर को अगर बेसिक लेवल की ट्रेनिंग दे दे तो वर्कर कर पाएगा. मतलब इट्स ओनली वी हैव टू गिव देम कॉन्फिडेंस प्लस ऑल्सो गिव देम इंसेंटिव्स ऑल्सो. अगर हम अपना फ़ायदा देखेंगे एज ए मैन्युफैक्चरर कि हमने टेक्नोलॉजी वर्कर टेक्नोलॉजी यूज़ करे लेकिन हमारे बेनिफिट के लिए, ताकि हमारी कैपेसिटी यूटिलाइजेशन इंप्रूव हो जाए, और वर्कर को कहाँ फ़ायदा मिला? अगर हम वर्कर को अगर कुछ इंसेंटिव्स देंगे सो दैट अगर हम 100 रुपये बचा रहे हैं एटलीस्ट 10 रुपये वर्कर के पास जाए, so that in some incentives then you see the level of an interest that the worker will bring in using the solution. And again, whatever I have written down here, I have all seen it, correct? I have all seen it. I basically worked in a plant which is a very small plant, जिसके साथ basically what we started doing is कि पहले supervisor ने data recording start करा, उसके बाद within 2 months it shifted to the worker. और now worker are very comfortable in doing the recording. It's only initially हमें डर लगता है, initially we have a fear within us, but once there are 2 or 3 months of a gap, I think things automatically stabilizes. So last slide for me basically is, अब इतना सब बात कर लिया, अब आगे बढ़ना कैसे है, करेक्ट? होना कैसे चाहिए? So this is what a plan basically what I am prescribing for all the mid-size manufacturing company. सबसे पहले स्किलिंग पर काम करिए, क्योंकि जब तक थोड़े लेवल की अंडरस्टैंडिंग नहीं होगी वो चीज़ को अप्रिशिएट नहीं कर पाएंगे. सो विच मीन्स एक बेसिक लेवल ऑफ ए ट्रेनिंग फॉर योर ऑर्गेनाइजेशन. इट विल बी जस्ट ए 1 डे ट्रेनिंग. कोई बहुत बड़ा इन्वेस्टमेंट नहीं है, बहुत बड़ा टाइम का वो नहीं है. एक दिन का बेसिक लेवल ऑफ ए टेक्नोलॉजी ट्रेनिंग विद इन योर ऑर्गेनाइजेशन हैज़ टू बी देयर, करेक्ट? आफ्टर दैट बेसिकली लुक एट क्रिटिकली एसेस योर प्लांट कि उसके अंदर कहाँ कहाँ पे जो डिजिटल अगर इंफ्रास्ट्रक्चर हो सकता है तो वहाँ पर कहाँ पे प्रॉब्लम आएंगी. अभी प्रोसेस लेवल पर क्या क्या गैप्स हैं, क्योंकि प्रोसेस लेवल को भी साथ में फिक्स करना है. इफ़ ए बैड प्रोसेस गेट्स डिजिटाइज इट विल गिव द बैड आउटकम्स, करेक्ट? सो प्रोसेस लेवल पर भी हमें चेंजेस पहले देखने हैं. हमें अपना ऑर्गेनाइजेशन स्ट्रक्चर्स को भी देखना है कि हम प्रोजेक्ट्स कैसे डिफाइन करते हैं, उसको एग्जीक्यूट कौन करेगा, कोर टीम कैसी होगी. सो देर आर बजट एलोकेशन उसका कैसा होगा. ये बड़ी कंपनीज में होते हैं लेकिन छोटी कंपनी में नहीं, बट समथिंग दैट यू रियली हैव टू एसेस. थर्ड इज़ द प्लान कि अगर हमें टेक्नोलॉजी में आगे जाना है तो हमारा प्लान क्या होगा. व्हाट विल बी माई 1 ईयर प्लान, व्हाट विल बी माई 3 ईयर प्लान. अगर मुझे 3 साल में कैपेसिटी यूटिलाइजेशन 6% अपनी बढ़ानी है तो उस 6% बढ़ाने के लिए मुझे पहले साल में क्या क्या स्टेप्स करने हैं, सेकेंड ईयर में क्या करने हैं, थर्ड ईयर में क्या करने हैं. आपके पास एक प्लान होना चाहिए. अगेन दिस डजंट हैपन इन एमएसएमईज, अगेन विच आई हैव सीन कि हमें जो चैलेंज है उसके लिए कोई सोल्यूशन लिया, बट बाद में पता लगा उस सोल्यूशन में हमने से 10 लाख रुपए लगा दिए. अगर उसी सोल्यूशन के साथ अगर 1 लाख का और कुछ ले लिया होता तो वैल्यू मिलती, अदरवाइज वैल्यू नहीं मिलेगी, करेक्ट? सो एक सीक्वेंस ऑफ स्टेप्स भी इंपॉर्टेंट रहते हैं टेक्नोलॉजी में कि पहले क्या करना है फिर क्या करना है. अगर हमने जो बाद में करना था वो सोल्यूशन पहले ले लिया और जो पहले लेना था वो बाद में लिया, तो आपको रिजल्ट्स नहीं मिलेंगे. करेक्ट. यू विल बेसिकली इट विल नॉट गिव द रिजल्ट्स, एंड देन वी से कि डिजिटाइजेशन में आरओआई नहीं आती. आरओआई नहीं आई क्योंकि वो स्ट्रक्चर्ड प्लान के बेस पे इंप्लीमेंट नहीं हुआ. करेक्ट. विच इज़ वाई प्लानिंग इज इंपॉर्टेंट. उसके बाद आई एम नॉट सेइंग कि आप पूरे प्लांट में बेसिकली सोल्यूशन एक साथ लगवाओ. अगर आपके पास 10 ऑपरेशंस हो रहे हैं तो आप 1 या 2 ऑपरेशंस को ही कवर करो इनिशियली. सी द हाउ टेक्नोलॉजी वर्क्स, सी द इम्पैक्ट, see the benefits, see how workers are getting comfortable, see how your organization is getting comfortable, और उसके बाद basically उसको scale करें. And यहाँ पर if you do follow this process, then the chances of success becomes more, investment becomes minimized. जो risk and reward मैं बोल रहा था कि अगर आप pilot करके फिर जाएंगे तो risk gets minimized. Correct? Because you have invested only at a small level. So अगर by chance कि pilot आपका successful नहीं भी हुआ, so you have lost only a small money. तो अगर 2-3 पायलट करेंगे तो कुछ ना कुछ तो सक्सेसफुल होगा ही. करेक्ट. सो विच इज़ वाई आई थिंक आरओआई को इतना स्टार्टिंग लेवल पर आरओआई नहीं देखना. एक बार पायलट हो गया उसके बाद डेफिनेटली वी हैव टू सी दी आरओआई. करेक्ट. सो आरओआई विल बिकम इम्पॉर्टेंट. वी ऑलवेज कैलकुलेट आरओआई. वाई डोंट वी कैलकुलेट अपॉर्चुनिटी कॉस्ट. अगर डिजिटाइजेशन अगर हम 1 साल बाद करेंगे, इस 1 साल में अगर हमने डिजिटलाइजेशन कर लिया होता तो कितना पैसा बचा लिया होता. दैट्स ऑल्सो एन अपॉर्चुनिटी कॉस्ट. करेक्ट. वी कीप डिलेइंग द डिसीजंस, और उस डिसीजन के डिले से कितना अपॉर्चुनिटी कॉस्ट बेसिकली लूज हो रहा है, वी डोंट गेट टू सी. सो इफ यू वांट टू डू आरओआई, डू एन अपॉर्चुनिटी कॉस्ट कैलकुलेशन ऑल्सो, देन यू विल फील. एंड देन अगर पायलट हो गया, सक्सेसफुल हो गया, देन यू मेक ए प्लान कि अब इसको कैसे प्लांट लेवल पर स्केल करना है. करेक्ट. सो दीज आर the ways. इसके लिए मतलब if you want, I mean we can also run it like a 6 months program. Correct. एक ग्रुप बना के 6 months का प्रोग्राम भी कर सकते हैं. मतलब if there are group of manufacturers who are ready to form a cohort kind of a thing, जिसमें सबका कॉमन ट्रेनिंग हो जाएगा. कॉमन ट्रेनिंग के बाद प्लांट का असेसमेंट होगा. बेस्ड ऑन दैट बेसिकली प्लान कैन गेट मेड और वन सोल्यूशन अडॉप्शन. सो आई एम सेइंग आई एम थिंकिंग ऑफ डिफरेंट वेज this really can be done to bring them to bring some level of a confidence to the industry. So digitization, basically I know I've talked about a lot about technology, but digitalization is no longer optional. I think ये सब आपने तो I think you would have heard it many times. It is no longer optional. It is a business survival and growth enabler. So that's the thing. I mean, I keep posting on LinkedIn. So अगर आपको टेक्नोलॉजी में इंटरेस्ट है, you can always follow me on LinkedIn. I basically regularly, daily basis, I post and I talk about what are the ways technologies can be applied to improve the efficiency, productivity in the manufacturing plant. So hopefully that will be of help to you. And great to kind of again present here. Thank you to the department for giving me this opportunity. As I said, I mean, it's basically my passion to help the industry. So whatever I can do, I'm more than happy to do anything. So hopefully it was helpful. I mean, I don't know whether we have time for questions or not. So. किसका? पायलट भी करना हो, अगर 2 या 3 इक्विपमेंट लेवल पर भी करना होगा तो 2-3 लाख से ज़्यादा नहीं आने वाला है. आप पायलट करिए ना, उसके बाद पूरे प्लांट में भी करना हो तो 5-6 लाख. हाँ, आप मैं तो सिर्फ पायलट करिए, पायलट के बाद रिजल्ट्स देखिए एंड देन बेसिकली यू गेट टू फील इट. श्योर. ओके, thank you very much.
Thank you, Mr. Saluja, for your very brief and very needful presentation and your speech. It is very much needful to all of them. We are very much glad and honored to have a valuable presence of Minister of State, Shri Jairam Bhai Gamit. I request Srimati Mamta Verma ma'am to please felicitate our Honorable Minister, Shri Jairam Bhai Gamit, with flowers. And with that, I request Mr. Chintan Thakur Chairman SHM, to please felicitate him with memento. Chairman SHM, Shintan Thakur, will felicitate our Honorable Minister with memento. Everybody put your hands together and let's welcome him. Thank you in the ceramic conclave for Viksit Bharat, quality meets global competitiveness. Now, I would like to invite our another speaker, Mr. Jagdish Shukla, Director from ServeLink System. He will discuss about advanced ceramics, emerging application and new market opportunities.
I'll speak without this thing. Sure. No problem. You can take. I'll just keep it in mind. Good afternoon. I'll not test your patience because there's a lot who have spoken about ceramic industry, the prospect in ceramic industry, the automation available in ceramic industry. I'll take forward on a journey of the ecosystem available in India with the ceramic industry. So I represent Automation Industry Association, which is available in India. I also represent a society called International Society of Automation, the society which works for last 80 years globally in almost all the countries. And primarily the focus of this society is setting the standard for automation for all the vertical of industries. So when I say automation industry, which is an apex body of automation, multinational automation company available in India, and also the solution providers, which are basically a system integrators. They become a part of this Automation Industry Association. And the primary focus of this is a vendor-neutral approach in developing educational curriculum for the university. That's one of the aspects which EIA works on. Promoting industry practices and skills, and also a global standard, because there are many global standards. So which standard where the industry can work upon, which is that. And about 2/3 of the variety of industrial use cases are available with the members of Automation Industry Association. So when we have this large number of the members associated with the society, we offer our solution in electrical automation, mechanical automation, continuous and batch process automation, robotics, machine vision, assembly and machine handling system, sensors, controllers, final control element, actuators, communication devices, HMI, real-time software, simulation and training. Mr. Amit Saluja has made my job very simple. Talk about smart manufacturing, the automation industry 4.0 requirement, and EIA is very well focused to help on smart manufacturing and the integrated control plant, which offers a good amount of ease of automation available, which will be subscribed in almost all the plants. So what we have seen, and he has already described, then the current plan, which were partly operated by the automation and partly operated by the operators, and especially ceramic industry is one of the sector where this thing is very much employed. The mechanized operation is very much high in that sector. Improved productivity over manual operation, which is already have been seen by you. There is a vital process parameter control which has been happening in that. Quality cannot be predicted when this kind of a control of both partly automated and the operator interface is available. Data analysis is not the key skill set, because to have the data you need to have a proper sensor in the plant. So that's what is requirement.
and the one aspect which we talk about, the safety standard, which has to be followed in this industry. So this gap which we have seen in the SME industry, and we thought that Automation Industry Association can help to overcome this gap, to need of making work smarter by employing the Industry 4.0 digital transformation journey, lack of data traceability which is there, which can be helped in this industry, requirement of operator upskilling. The workforce skill set upgradation is very much required when you employ this digital transformation journey. Then struggling with the end of the line quality assurance plan, ineffective maintenance management. He talked about the predictive maintenance which is required, and upgrading document management, which is one of the vital aspects which is required in this industry. So converting the old assets with the smart automation, he has already covered the aspect on speed, feed, and document and the vibration, which is the aspect which are very vital thing. And believe me, I also firmly say automation is the enabler to help you to improvise the productivity of your plant, to also have a proper improvisation in the quality aspect of your product, and also to overcome the competitiveness with which your plant are facing in the industry. So product quality, main machine health, and operator guidance, all three aspects are get covered in this industry. With this initiative, Department of Heavy Industry, Government of India came out with an initiative of the vision for fueling the manufacturing leadership, and smart manufacturing is one of the aspects. So Automation Industry Association, with the help of Department of Heavy Industries, have created a center of excellence. One such center of excellence is created in IIT Delhi, and with the help, which is basically helping industry educating about Industry 4.0 digital transformation journey, but at the same time, how that particular industry can make use of digital transformation journey. And that center of excellence have, recently the question was asked whether what we can deploy and all. So to try out even at proof of concept level, center of excellence can help you to join on this hand. So all the three aspects, main, machine, and the method, when I say process, all three combines can be helped in this process of managing. Such one of the center of excellence is also developed in Gujarat. It is with BVM Engineering College in Vallabh Vidyanagar. They have also working on the same aspect, and AIA, our Automation Industry Association, is also helping them to overcome on the aspect. All those four aspects of the productivity, quality, reliability, safety, and traceability will be taken care through this initiative of that. Facility for showcasing the emerging technology is the what our FSM, Factory Smart Manufacturing Simplified Process program, is available with AIA, and which is also helping on building up the capability to digitalize physical world for real-time information, data visualization, data analysis, remote maintenance, smart sensing, smart machine interface, digital twin, artificial intelligence and machine learning, augmented reality, and collaborative robot. So to touch upon, we have seen the pain point. In fact, when I was listening the previous speakers, one of the pain points they listed was the energy consumption in the ceramic industry. Likewise, there are other many area of the pain points are there related with the recipe mixing, which is also slurry to powder when you use the spray dryer, how the maximum utilization of the spray dryer happens, press section, kiln automation, which has also, and also there is a scope of an automation which can be thought about in the warehouse, even on the shop floor, lifting, sorting, loading, as well as in a storage facility which is required. And we are here, Automation Industry Association, as well as both our member who are associated with this to take care of their part. I will also once again talk about the myth that automation technology is costly is a myth, and that prevails not only with ceramic industry, even it prevails with almost all vertical of industry, but it needs to be treated that the investment in automation, the investment in digital transformation journey is to be taken as an investment, and when you treat that as an investment, I'm sure you will definitely accrue a return of investment in a progressive way if it is planned a proper way. That's what my subject and my message would be. So type of automation which ceramic industry can think about is the smart sensor, uses of smart sensor, which is one of the aspects which I will say. Recipe mixing automation, one of the aspects. Vision-based quality control. And he also touched upon about the uses of camera for vision-based. So on inspection as well as the quality control part, this will be very used. IoT-based application can be deployed in various sector of the ceramic industry. Dashboard, you talk about the dashboard, and dashboard will definitely facilitate the operator with a very ease of the plant operation. Smart manufacturing industry 4.0 deployment, uses of the robots and cobots, both. You use either robot or you have a collaborative robot in your shop floor can also help. And also, I would say like for workforce development, a training simulator can also be a part of the phase which can happen in this ceramic industry. I will send my presentation and they can share with you because unfortunately that presentation was shared but was not available here, so I could not show. But our contact details are available and we are there to help you out as and when you need it for your automation journey. Thank you. Thank you so much.
Everybody, let's welcome Honorable Union Minister Shri Piyush Goyal sir. जोरदार तालियों से हम स्वागत करेंगे माननीय श्री पीयूष गोयल सर का. साथ में our Honorable State Minister Shri Jairam Bhai Gamit and Shri Hasmukh Bhai Adia, आप सभी का स्वागत करते हैं. Requesting Srimati Mamta Verma ma'am, ACS Industries, to please felicitate Honorable Union Minister Shri Piyush Goyal sir. Everybody. Requesting Mr. Chintan Thakur, SHM, to please give memento and felicitate our Honorable Union Minister. Requesting once again Shri Chintan Thakur sir to please felicitate Hasmukh Adia sir. We welcome you, sir. This is the very purposeful and a wonderful session on ceramics, Gujarat, Vibrant Gujarat Regional Conferences of Kutch and Saurashtra. And we are really glad and honored to have a valuable presence of Honorable Union Minister Shri Piyush Goyal sir. So with your clappings, I request him to please speak few words to the august audience. Please, sir. Yeah.
माननीय मंत्री जयराम भाई, हसमुख भाई, सभी मंच पर और साथ में यहाँ बैठे सम्माननीय महानुभाव मित्रों, जब हसमुख भाई ने बताया कि अभी सेरामिक इंडस्ट्री के साथ इंटरेक्शन है, तो मैंने कहा ये तो मेरे घर की इंडस्ट्री. चिंता मत करो, मैं आपका कॉम्पिटिटर नहीं बन रहा हूँ. पर लगभग मुझे लगता है 6-7 सालों से मेरा सेरामिक इंडस्ट्री के साथ लगातार मिलना जुलना रहा है, चर्चा होती रही है. मोरवी भी आया हूँ और कुछ प्लांट्स भी देखे हैं मोरवी में मैंने. और वास्तव में सबसे पहले तो आप सबका साधुवाद करना चाहूँगा जो आपने लाजवाब काम करके देश का नाम रोशन. મને વાસ્તવમાં તમારી વચ્ચે આવવાનું બહુ જ અભિમાન છે, બહુ ખુશી થાય છે તમારી વચ્ચે. આ પ્લેટફોર્મ ये जो प्लेटफॉर्म माननीय प्रधानमंत्री जी ने कल्पना की है रीजनल कॉन्फ्रेंसेस की, मैं समझता हूँ इसका बहुत बड़ा लाभ सेरामिक इंडस्ट्री को होगा, क्योंकि एक पहचान बनेगी दुनिया में। ये इंडस्ट्री की काबिलियत पिछले साल भारत बिल्डकॉन में पहली बार बड़े पैमाने पे सामने आई। इस बार वापस भारत बिल्डकॉन अप्रैल में है, 29 अप्रैल से है। और सिर्फ सेरामिक नहीं, उसमें तो एक प्रकार से बिल्डिंग इंडस्ट्री को इन्होंने जोड़ के एक मैक्रो लेवल पे क्या क्या लगता है उन सबको मौका दिया है प्रेजेंट करने का। पर अब ये रीजनल कॉन्फ्रेंसेस से भारत की सेरामिक इंडस्ट्री की ताकत और ज़्यादा लोगों तक पहुँचे, इनकी कुछ समस्या हो तो वो भी हाईलाइट हो जाए, उसके लिए क्या इंफ्रास्ट्रक्चर चाहिए, क्या और सुविधाएं देने से इंडस्ट्री और ग्रो हो सकती है, कैसे क्वालिटी के ऊपर फोकस किया तो संभावनाएं बढ़ सकती हैं, किस प्रकार से स्केल बढ़ाएं तो हम बड़ी मार्केट विश्व की कैप्चर कर सकते हैं। मुझे लगता है कि एक डिटेल्ड अगर हम सब मिलके प्लानिंग करते हैं, आज के दिन कितना एक्सपोर्ट हो रहा है सेरामिक का? 18,000 करोड़। हमारा 5 साल आगे का लक्ष्य क्या रखा है हमने? 35,000, डबल करेंगे उसको। ऐसा है, प्रधानमंत्री मोदी जी ने हम सबको बिगाड़ दिया है। आप जो भी बोलोगे उससे संतुष्टि नहीं होती है। और ये मेरे साथ 2-3 जगह हुआ, लेकिन हर बार हम सही निकले। मैं उदाहरण देता हूँ आईटी इंडस्ट्री का। आईटी इंडस्ट्री से जब मैं मुलाकात करता था तो वो टारगेट देते थे, मैं उसको और ऊंचा टारगेट देता था, अगली बार आते थे अचीव करके आते थे। ऑटो कंपोनेंट्स, जिसमें राजकोट का भी बहुत बड़ा हाथ है, जब भी वो आके बोलते थे हम इतना हमारा एक्सपोर्ट का प्लान है, मैं उसको और बढ़ाता था और वो अचीव करके आते। पिछली बार जब एक्मा की मीटिंग हुई ऑटो कंपोनेंट मैन्युफैक्चरर्स, मेरे भाषण के पहले ही उन्होंने बोल दिया कि आप बढ़ाओ, उसके पहले ही हम आपको बता देते, हमने अपना टारगेट ही इतना बढ़ा दिया। तो ऐसे ही मैं टारगेट देने के बदले आप लोग एक छोटे ग्रुप में बैठिए, पूरी इंडस्ट्री को साथ में लेके बैठिए और सोचिए कि विश्व की मार्केट कितनी बड़ी है। अभी हम फ्री ट्रेड एग्रीमेंट्स भी कर रहे हैं, और ध्यान रखिए हम कांग्रेस की तरह हमारे कॉम्पिटिटर के साथ फ्री ट्रेड एग्रीमेंट नहीं कर रहे। जैसे आसियान एग्रीमेंट, अब थाईलैंड वियतनाम तो आपका कॉम्पिटिटर है, उसके साथ एफटीए करके तो हमें नुकसान है। हम मोदी जी ने 7 एफटीए किए हैं अभी तक। मॉरिशस $20,000 से ज़्यादा पर कैपिटा इनकम, न्यूजीलैंड ऑस्ट्रेलिया $50,000 का पर कैपिटा इनकम, स्विट्जरलैंड, लिechtenstein, आइसलैंड और नॉर्वे, चारों मिलाए तो $1,00,000 से ज़्यादा पर कैपिटा इनकम। $1,00,000, यानी उस देश की अर्थव्यवस्था में हर एक व्यक्ति जो है उसका उत्पादन 90 लाख करोड़ रुपए। हमने यूके के साथ किया $50,000 का पर कैपिटा। यूएई, ओमान, दोनों आपके बड़े डेस्टिनेशन है सेरामिक के, और दोनों में सुनिश्चित किया है कि सेरामिक के ऊपर एंटी डंपिंग ड्यूटी जो लगाई है जीसीसी ने वो नहीं लगे। तो मोदी जी कितनी गहराई और छोटी छोटी बातों की चिंता करते हो, आप कल्पना करिए कि हमारी मोरवीમાં सेरामिक इंडस्ट्री છે, એને નુકસાન થાય છે આ એન્ટી ડમ્પિંગ ડ્યુટીની, તો અમારી જિમ્મેદારી થઈ કે અમે મહેનત કરીએ કે કેવી રીતે એન્ટી ડમ્પિંગ ડ્યુટી હટશે। તમને ખુશખબરી આપવા માંગુ છું કે જીસીસી પણ હવે આવી ગયો છે એફટીએ કરવા માટે। તો જો 2-3 દેશ છે, સાઉદી અરેબિયા લગાવે છે મને લાગે છે, ત્યાં અમે ટ્રાય કરશું કે ત્યાંથી પણ હટે. कहने का तात्पर्य ये है कि आप लोग प्लान करिए. एक सिर्फ टारगेट फिगर देने से फायदा नहीं है. देखिए तो सही अंतर्राष्ट्रीय मार्केट कितनी बड़ी है, फिर हमारी स्ट्रेंथ्स क्या है, हमें क्या और ज़रूरत है जिसमें सरकार हेल्प कर सकती है. और मेरा मानना है कि अगर आप दो चीज़ों पे फोकस करें, एक क्वालिटी और एक सस्टेनेबिलिटी, क्योंकि आज यूरोप में आपको कुछ सामान बेचना है तो आप बोलोगे हमने रिन्यूएबल एनर्जी लगा के इसको बनाया है, हमारा नेट ज़ीरो इम्प्रिंट है हमारी मैन्युफैक्चरिंग फैक्ट्री का, तो आपको प्रीमियम प्राइसिंग भी मिलेगी. सस्टेनेबिलिटी में ताकत है और क्वालिटी का तो कोई मुकाबला ही नहीं है. अगर हमने क्वालिटी में, और ये ध्यान रखें आपके कुछ 180 या कितने 600 कितने प्लांट्स हैं, 800 प्लांट्स हैं, हाँ मैं भूल रहा था नंबर. अब 800 प्लांट में ये ध्यान रखें कि एक आदमी गलत काम करेगा तो उसका खामियाना 799 लोगों को भुगतना पड़ेगा. एक आदमी का गलत काम, क्योंकि रेपुटेशन और क्रेडिबिलिटी अमूल्य है, उसका कोई मुकाबला नहीं. और भारत मेड इन इंडिया, भारत में बना हुआ 1 2 3 आदमी का सामान जब मार्केट में जाता है और अच्छा परफॉर्म नहीं करता है तो उससे पूरी इंडस्ट्री को, भारत की ब्रांड को, भारत की इमेज को नुकसान पहुंचता. तो इसमें सबका सामूहिक प्रयास होना चाहिए. अगर हम में से कोई पीछे रह गया है क्वालिटी के सिलसिले में, हमने या तो उसको उठाने की कोशिश करनी चाहिए या विसल ब्लोअर बन के उसको ब्लैकलिस्ट कराना चाहिए. मैं तो मानता हूं आप लोगों ने क्यूसीओ के ऊपर प्रयत्न करके लगवाना चाहिए कि कोई भी व्यक्ति खराब माल नहीं बना सके. स्ट्रिक्ट क्वालिटी कंट्रोल हो, लैबोरेटरीज को मॉडर्नाइज करें. देखिए जाके दुनिया में मोस्ट मॉडर्न लैबोरेटरी किस देश में, मोस्ट मॉडर्न इक्विपमेंट क्या है. हम आपको सरकार से फ्री ऑफ चार्ज BIS इन्वेस्ट करके आपको मोस्ट मॉडर्न लैबोरेटरी के इक्विपमेंट को खरीद के देंगे. आपका मोरबी इंडस्ट्रियल एसोसिएशन है या सेरामिक एसोसिएशन है या कोई सरकारी लैबोरेटरी हो, उसमें लगाना पड़ेगा, प्राइवेट को नहीं दे सकती सरकार. पर BIS खुद के पैसे से, पर एक ही शर्त, सेकंड बेस्ट नहीं होना चाहिए. हमारी लैब दुनिया की बेस्ट लैब में आए तभी स्वाद है, तभी फायदा है. और अगर हमने क्वालिटी और सस्टेनेबिलिटी को वर्ल्ड क्लास, या रादर मैं तो कहूँगा एक कदम आगे जाने का प्रयास किया, तो ईमानदारी से वर्ल्ड की मार्केट आज इतनी बड़ी है कि आप रोजगार का भी बड़ा साधन बनेंगे, आप व्यापार का भी बड़ा साधन बनेंगे, फॉरेन एक्सचेंज अर्निंग करेंगे, निर्यात से भारत का नाम रोशन करेंगे, आपके बिजनेसेस ग्रो करेंगे. और हो सकता है नए लोग भी शुरू करें, उसमें क्या नुकसान है. स्पर्धा तो हम सबको एफिशिएंट बनाएगी. पर मुझे लगता है सेरामिक एक ऐसी इंडस्ट्री है जिसका भारत में भी अपार संभावनाएं है. आप देखिए कितना कंस्ट्रक्शन हो रहा है. आप मेरी कॉन्स्टिट्यूएंसी में आ जाइए, उत्तर मुंबई, आपको इतनी बिल्डिंगें दिखेंगी, शायद पूरे राजकोट में नहीं बनती होंगी, पूरे आधे गुजरात में नहीं बनती होगी. उतना कंस्ट्रक्शन एक ही जगह पे चलेगा. आप मुंबई तो जानते होंगे, बोरीवली, कांदिवली, सब गुजूभाई बहन रहते हैं वहाँ पे. और मैक्सिमम कंस्ट्रक्शन, कितना डिमांड है भारत में. लेकिन जब आप अंतर्राष्ट्रीय डिमांड के लिए अच्छी क्वालिटी बनाएंगे तो भारत के उपभोक्ता को भी आपको वही अच्छी क्वालिटी देनी. तब जाके हम इंपोर्ट को भी रोक पाएंगे, तब जाके हमारे यहाँ के बनाए हुए सामान की डिमांड बढ़ेगी. और मुझे लगता है कि ये जो माननीय प्रधानमंत्री जी की कल्पना है रीजनल कॉन्फ्रेंसेस की, इसका बहुत बड़ा लाभ आपकी इंडस्ट्री प्राप्त कर सकती है. प्रधानमंत्री जी अलग अलग एरियाज़ को डेजिग्नेट भी कर रहे हैं इंडस्ट्रियल क्लस्टर्स के रूप में। 100 और इंडस्ट्रियल पार्क जल्दी केंद्र सरकार कैबिनेट पास करेगी, बजट में अनाउंस किया था। हो सकता है आपका डिमांड आए और राजकोट से अगर कलेक्टर प्रपोजल भेजता है या राज्य सरकार भेजती है तो सेंट्रल और स्टेट मिलके एक सेरामिक पार्क, इंडस्ट्रियल पार्क भी हम बना सकते हैं यहाँ पे, फोकस्ड आपकी इंडस्ट्री के लिए। आपको अच्छी इंफ्रास्ट्रक्चर मिलेगी, अच्छी सुविधाएं मिलेगी, गैस पाइपलाइन हर फैक्ट्री तक जाए उसको सुनिश्चित कर सकते हैं, क्वालिटी लैब्स मॉडर्न हो, पावर अनइंटरप्टेड हो, स्किल डेवलपमेंट सेंटर हो जिसमें आपके कामगारों को अच्छी स्किल डेवलपमेंट हो सके, मशीनरी मैन्युफैक्चरिंग की फैसिलिटी भी वहाँ लाएं जिससे आपको मशीनों के लिए चाइना नहीं जाना पड़ेगा, विदेश से मशीन नहीं लानी पड़ेगी। राजकोट के लोग ही सबसे बेस्ट मशीन बना देंगे आपके लिए। अच्छा, और यूनिक प्रोडक्ट्स। आज ज़माना ऐसा है कि नए डिज़ाइन, नए फैसिलिटीज़। आप याद करिए जापान ने वो ऑटोमेटिक पॉट बनाया था, करेक्ट? जापान से शुरू हुआ था ना वो टोयो वगैरह के जो ऑटोमेटिक, जिसमें हर एक चीज़ इलेक्ट्रॉनिक है। अब उन्होंने नई सोच से नई चीज़ बनाई, वर्ल्ड मार्केट में कितना प्रसिद्ध हुआ। आप लोग भी नई नई चीज़ें, नए डिज़ाइंस, नई फैसिलिटीज़, अच्छी सीलिंग हो, वाटर का कोई बैकअप का कोई प्लान बनाओ। आई डोंट नो, मैं इंडस्ट्री इतनी नहीं समझता हूँ, पर आप कोई यूनिक चीज़ें, जैसे पीछे एक यूनिक चीज़ मैंने भी देखी थी, वाटरलेस फ्लश यूरिनल्स के लिए। अब पता नहीं भारत में भी बन रहा है या विदेश से आ रहे हैं। स्मार्ट टॉयलेट विदेश से आ रहे हैं, तो ये तो एक्सेप्टेबल नहीं है। हमारे पास इतना सामर्थ्य है, हमने बनाना चाहिए। हमारे पास इतनी ताकत है कि हमने फोरफ्रंट ऑफ इनोवेशन एंड टेक्नोलॉजी में रहना है। और मुझे विश्वास है फिर ये 35,000 ये वो बहुत मामूली लगेंगे। कैपेबिलिटी और कैपेसिटी देखो तो आपकी क्षमता तो कई गुना छलांग लगाने की। और अगर आपने छोटा सोचा तो एक प्रकार से अगर कोई सबसे ज़्यादा दुखी होगा तो माननीय प्रधानमंत्री नरेंद्र मोदी होंगे कि मेरे गुजरात के लोग छोटा कैसे सोच सकते। उनको तो बड़ी छलांग। और अगर हमें विकसित भारत बनाना है तो विकसित गुजरात तो बनेगा ही, विकसित सौराष्ट्र बनेगा ही। तो उसकी नींव शुरुआत क्यों ना हम विकसित मोरबी से करें। तो मित्रों, अच्छी हाई क्वालिटी प्रोडक्शन, सस्टेनेबल प्रोडक्शन, ऑनेस्ट प्रोडक्शन, हमें कभी भी कॉम्प्रोमाइज अपने इंटेग्रिटी पे नहीं करना। इंटेग्रिटी इज नॉट ओनली फाइनेंशियल, इज ऑफ कोर्स इंक्लूड्स फाइनेंशियल इंटेग्रिटी, बट इंटेग्रिटी टू व्हाट वी गिव टू द कस्टमर, इंटेग्रिटी टू फुलफिलिंग प्रोमिसेस। आप अगर एक टाइमलाइन देते हो कि आपका सामान समय पे पहुंचता है कि नहीं, आप अगर एक क्वालिटी दिखाते हो तो क्या आपकी पूरी सप्लाई वही क्वालिटी है या उसमें कुछ कमी काट दी, कुछ कॉम्प्रोमाइज़ किया। ये चीज़ें डिफाइन करती हैं भारत की छवि को भी, इंडस्ट्री की छवि को भी और इंडस्ट्री के भविष्य को। और आप सबसे मेरी हाथ जोड़ के विनती है, आप भारत के ब्रांड एम्बेसडर्स हैं। आपको भारत का नाम रोशन करना है, आपको भारत के ब्रांड को अंतर्राष्ट्रीय ब्रांड बनाना है, आपको भारत की इमेज को 4 चांद लगाना है। और अगर ये लक्ष्य लेके चले तो प्रॉफिट, ग्रोथ, एक्सपेंशन वो सब तो ऑटोमेटिक आएगा। उसके लिए आपको मेहनत नहीं करनी पड़ेगी। आपकी मेहनत होनी चाहिए ब्रांड की, ब्रांड बिल्डिंग की, टाइमली डिलीवरी की, इनोवेशन की, हाई क्वालिटी फोकस की, एक बार आपने उस पर फोकस किया, द रेस्ट विल फॉलो ऑटोमेटिकली। किसको कोई डाउट है इसमें? कोई असहमत है इसके साथ? तो मैं आज यहां से जब जाऊं तो जीतू भाई भी अभी आ गए। जीतू भाई यहाँ के पालक मंत्री भी हैं और ऋषिकेश मोरबी डिस्ट्रिक्ट अलग है। એમ બહુ સારું।
Sir, we have
तो
our,
बहुत टाइम से डिमांड
we have our president of association here.
₹4.5 જે ગુજરાત ગેસમાં જે ભાવ ઘટાડો કર્યો અને બીજા ₹2 પણ હજી અમને કીધેલું છે કે આવતા મહિનામાં હજી પણ ઘટશે અને ઇન્ડસ્ટ્રી હા ₹6 સાહેબ એટલે અમારા માટે બહુ મોટી હા અને રોડ બધા ઇન્ફ્રાસ્ટ્રક્ચર અમારા અંદાજે 96 રોડ જે છે એ પણ મંજૂર થઈ ગયા છે, એમાંથી 36 થી 40 રોડ જે છે એ બધા કામ પૂરા થઈ ગયા છે। અત્યારે ગુજરાત સરકારનું કામ ભૂપેન્દ્રભાઈ સરકારનું કામ બહુ સરસ ચાલી રહ્યું છે અને આપણા યશસ્વી વડાપ્રધાન શ્રી નરેન્દ્રભાઈ મોદી સાહેબના નેતૃત્વ હેઠળ સાહેબ ઘણા કરોડો ફાયદો થશે, કરોડો।
आपकी जानकारी के लिए आज के दिन सेरामिक की ग्लोबल मार्केट जो है वो 8 से 9 लाख करोड़ रुपए की है। 8 से 9 लाख करोड़। तो ये जो स्टेप्स लिए हैं इंफ्रास्ट्रक्चर डेवलपमेंट, रेट कम करने के, इसका लाभ आप कैसे ज़्यादा से ज़्यादा लें, तो आपके पोटेंशियल कहाँ तक है मैं आपको सिर्फ दर्शा रहा हूँ। और प्रधानमंत्री जी स्वयं इतने सारे कदम उठा रहे हैं, जीएसटी कम किया, रिफॉर्म कर रहे हैं अलग अलग प्रोसेसेस को, कंप्लायंस कम कर रहे हैं, सुविधाजनक बना रहे हैं कि आपको अफसरशाही से मुक्ति मिले, रोज़मर्रा की प्रॉब्लम्स कम हो। जीएसटी आ गया, आप भूल गए हो, दुर्भाग्य क्या है जीतू भाई, आस्ते आस्ते 6 महीने बाद 6 रुपए भूल जाएंगे। आप याद करो जीएसटी आने के पहले, बाकी तो छोड़ो कि स्टेट के इंटर स्टेट सेल की क्या प्रॉब्लम होती थी, कितने चेक नाका, क्या पेपर वर्क, सी फॉर्म याद है? सी फॉर्म और सी फॉर्म आज भी 8 साल हो गए खत्म हुए, आज भी लोग रिकंसाइल कर रहे हैं सी फॉर्म को पुराने। उसका एक वो जन विश्वास लाके या विवाद से विश्वास लाके निपटा दो यार सबका। पर रियली क्योंकि मैंने अपना लाइफ भी एक स्मॉल स्केल इंडस्ट्री से शुरू की थी। ऐसी मुसीबत थी और ये सब हम भूल गए हैं। अलग स्टेट के अलग रेट, पेपर वर्क, चेक नाका, रिश्वतखोरी, ये सब जो प्रधानमंत्री मोदी जी ने पिछले 25 साल में सरकार में, पहले गुजरात फिर केंद्र में, बेदाग, आप याद करिए ऐसा कोई राजनेता आपने देखा है? 50 साल का समाज सेवा, 25 साल सरकार में सेवा, बेदाग, एक दाग नहीं। पर फिर उनकी अपेक्षा आपसे भी यही है, ईमानदारी से हम अपना व्यापार करें, ईमानदारी से हम अपनी टैक्सेस भरें और ईमानदारी से भारत का नाम दुनिया में रोशन करें। उनकी तो इतनी अपेक्षा आपसे और कुछ नहीं है। और मुझे विश्वास है कि आप सब इस ब्रांड इंडिया को कायम रखने में, ब्रांड इंडिया को और आगे लेके जाने में कोई कसर नहीं छोड़ेंगे। आप सबको मेरी बहुत बहुत शुभकामनाएं, भारत बिल्डकॉन को भी बहुत बहुत शुभकामनाएं। और मेरे लायक कुछ कभी काम हो तो मेरे रास्ते, मेरे दरवाजे आप सबके लिए ऑलवेज खुले हैं। शुभेच्छा, बहु बहु आभार, धन्यवाद।
थैंक यू सो मच सर, बहुत बहुत धन्यवाद सर। आपकी अनुमति से यहाँ पे छोटे से एमओयू 1460 करोड़ के, अगर आप अनुमति दे तो करना चाहते हैं। हाँ, 1460 करोड़ के एमओयूज, रिक्वेस्टिंग नील श्रीमाली जी, जॉइंट इंडस्ट्रीज कमिश्नर, टू प्लीज exchange the MOUs. Simpolo International Private Limited, Sophostone LLP, सिम्पोलो से 780 करोड़ के एमओयूज सरकार के साथ यहाँ पे एक्सचेंज होंगे। बोफोस्टोन एलएलपी से 150 करोड़ के ये एमओयूज, ओको टाइल्स एलएलपी 200 सीआर एंड लेवेनो सरफेस 130 करोड़ और ब्लू जोन वर्टिफाइड से 200 सीआर के एमओयू यहाँ पे एक्सचेंज होने जा रहे हैं, जिसमें 1260 से ज़्यादा युवाओं को रोजगारी मिलेगी। जोरदार तालियों के साथ हम अभिवादित करिए शानदार वाइब्रेंट गुजरात कच्छ सौराष्ट्र रीजनल कॉन्फ्रेंसेस में। हम सभी के लिए बड़ी खुशी की बात है, ऑनरेबल यूनियन मिनिस्टर श्री पीयूष गोयल जी हमारे बीच हैं, साथ ही में स्टेट मिनिस्टर श्री जयराम भाई गामित, श्री जीतू भाई वाघाणी तथा सौ महानुभावों सरदय। Ceramic Conclave for Viksit Bharat, Quality Meet, Global Competitiveness. He's from Italy with us, so Mr. Roberto is there. हाँ बाकी थैंक यू सो मच वंस अगेन, बहुत बहुत शुक्रिया, बहुत बहुत धन्यवाद ऑनरेबल यूनियन मिनिस्टर श्री पीयूष गोयल जी का, साथ ही में पधारे हुए मंत्रीगणों का भी हम सहृदय आभार प्रकट करते हैं। धन्यवाद। ये कॉन्क्लेव अभी कंटिन्यू है। आई एम रिक्वेस्टिंग एवरीवन टू प्लीज बी सेटल्ड, प्लीज बी सीटेड। Thank you once again. Thank you everyone. We are open for lunch. Thank you.